Okay, good morning or afternoon or maybe evening in some places, everyone. Welcome to the Network Performance and Monitoring Workshop that's been kindly organised by the GÉANT project, Work Package 6, Task 3. I think one of the real strengths of the GÉANT community is how it collaborates, and particularly the project, where you have so many NRENs and university staff collaborating and sharing ideas. And today, obviously, we're taking that further. We have a number of speakers from elsewhere in the world, particularly the US. And so, this is a big international community, research and education. And one of the strengths of the R&E community is, it's very collaborative, very wanting to share, and that's one of the strengths of it. And hopefully, today we'll see good examples of this in action. Today's agenda is particularly focused on network performance and monitoring, and that with an operational perspective. So the tools we have and how we use them. And we have talks both from developers of tools, and you hear many of those in particularly the first session, and the operators and what they're doing with them. So later on, we'll hear how, so for example, ESnet and RNP are doing their monitoring. And the trick, of course, is to try and match the tools that we have and that we develop to the requirements of the users, be that the NRENs, the campuses, universities, etc., and to continually review what's working well, what doesn't work so well, what are the gaps, and particularly for the R&D community, where can we work together? There's always interest in sharing data. That raises a lot of thorny issues around privacy, etc. But it's in our interest to work together and to share data between organizations. And I think the strength of interest in this topic, it's evidenced today by the fact there's over 100 people registered for this event. That's pretty big for this type of event. If you want to look at the slide decks and recordings, they'll be posted to the event page there after the event. Some of the slide decks are up there. My deck is, I was able to upload that myself, so that's there now. The others will follow shortly. And I think the final thing I'll just say here is please do ask questions. There are Q&A slots. I don't know if questions will also be taken during the presentation, but asking questions, interacting, that's the best way to make the most of today's event. So please do stick your hand up and ask questions. So this isn't the first one of these types of event. There have been a number before it, run under the previous GÉANT project and the NGN SIG. If you want to see what sort of talks were given at those, then please look at those links. Again, the slides are on the event page, so you can go and follow down into those. I do remember being at the Performance Management Workshop in Zagreb in 2020. That, I think, was my last trip before COVID. I remember there was there was little bottles of gel and so on to wash your hands. It was clearly just as things were beginning to get concerning. And of course, since then, you'll notice all the events have been online. But being online, it does allow a lot more people to easily attend. On to today's agenda. As I said, it's a mixture of developers talking about their tools and operators talking about what they're doing and how they're doing it. So in the first session, we open with Lætitia talking about perfSONAR and the upcoming 5.1 that's got all the lovely Grafana visualizations in it, which a lot of us are looking forward to. There's TimeMap, which is more focused on looking at latency in particular. We'll hear from GÉANT, from Will, what they're doing for performance monitoring. And then Keith with the beautifully named Brian, Backbone Router Interface Analytics. That's the tool that lets you see the traffic levels on various links between GÉANT, within GÉANT. So for example, for me, that shows us the traffic between the GANET network in the UK and GÉANT, which has been very busy in the past few hours with the CERN Data Challenge 24 just starting this week. We're seeing our 300 gig link get quite full. There's GÉANT WiFiMon, which is the campus Wi-Fi monitoring tool. Nikos will talk about that. And then in the second part of the session, we have NetSage, which is this lovely tool for aggregating different data sources and presenting them through some very innovative visualizations. Doug will talk about that. We have Luke talking about the global NOC troubleshooter. And then we have ESnet, Internet2, and RNP talking about how they're doing performance monitoring, particularly with perfSONAR from Mike and Daniel. I've seen a US perfSONAR mesh with, it looked like about 50 nodes on it, and testing up to over 50 gig single stream, which was very impressive, using, I think, some of the latest tricks of TCP BBR and the Ether test tool, etc. But we'll hear more about them in the afternoon. And then Q&A again before we close. So lots to hear about today. First up is Lætitia, who's going to be talking about perfSONAR. I'm really interested to see, well, I kind of know what's coming, but I'm sure everyone else will be interested to see particularly what's coming with the new visualizations and Grafana. So I'll stop sharing here and hand over to Lætitia.
Yeah. Thank you, Tim. So I'll be talking today about the upcoming version of perfSONAR. It will be perfSONAR 5.1. So for those of you who don't know what perfSONAR is, but I guess that's a lot of people here, it's an open source software collaboration between 6 international organizations: ESnet, GÉANT, Indiana University, NTUA, RNP, and the University of Michigan. It's a collaboration that's lasting for some years, nearly or about 20 years, in fact. And it's a tool or toolkit to do network measurements and help identify and troubleshoot network performance issues. So last year we released perfSONAR 5.0 in April last year, and at the moment we have a bit more than 60% of all public perfSONAR deployment around the world that are running this new version. And the last time I looked yesterday, there was 2,200 public perfSONAR nodes active yesterday. This 5.0 version contained also new pScaler test plugin, mainly about Wi-Fi monitoring, and added also support for some newer operating system, not the latest, but still the EL8, EL9, and Ubuntu 20. But the most important thing in 5.0 was the replacement of the backend solution. So we had a homegrown solution in the past that was called ESmont, and with 5.0 last year, we replaced it with OpenSearch. And that adds possibilities to access the data and then to visualize it and to analyze it. So with version 5.1, we as developer wanted to focus on improving the UI and take out some benefits of this new backend and the access to the data. So for that, we decided that we will move to a new user interface for the perfSONAR toolkit based on Grafana. So if you've played with the perfSONAR toolkit 5.0 last year, starting last year, you've probably seen that we had a Grafana cookbook that already enabled you to put together, to access the OpenSearch data and put together dashboards using new panels with perfSONAR data. And we want to bring that by default to all perfSONAR users. What we truly want to do is to focus on the measurements. So provide a dashboard like the following one, where you clearly can see what is the network parameters that perfSONAR is monitoring, and what are the results of the test right at the moment and in the past, in the past hours or the past days or the past week, so that you can see the evolution of these parameters. So we built some new new dashboard and new panels with Grafana. Another one is this one showing the throughput, the latency, and the retransmit over time between two perfSONAR hosts. And of course, you can choose the source and destination host as you wish, and schedule the new measurements, new tests through the UI. Let's show you a few more examples of what you'll be able to see in the new toolkit UI, with also access to some new information. So we wanted to also let perfSONAR users know about the status and clearly know about the status of the different services that are running on a perfSONAR node. So we will have installed by default on a perfSONAR toolkit the Prometheus node exporter that and stored that data in OpenSearch as well, so that you can display it and look at its evolution over time, so that you know if your system is behaving fine or not. And you can compare as well the status of the different services with your measurements in case something is not behaving as expected. So here on the left, you see the list of all services and the status. On the right, it's a screenshot of the pScheduler statistics, so the number of pScheduler tasks that are currently running and scheduled, and how the archiving is going. Using Grafana, one very powerful feature is the data correlation. So we can put on the same dashboard or even on the same panel different kind of information. So an example here is where we plot the usage, the host usage, the host metrics, for example, the memory and the CPU utilization, together with the time where Hyper-3 is running. So you can see that the network spike are directly created by the Hyper process running. And you can see that it has nearly no impact on the CPU usage or the memory usage. And as well, you can correlate network performance measurements together, so you could see whether a throughput measurement will have an effect on a latency measurement or on jitter, for example. One important tool in the perfSONAR portfolio is MatDash. We wanted also with this new version to replace it and to integrate it into Grafana, in the Grafana UI, because we prefer to have a single user interface front end instead of having to maintain multiple ones. So one of the perfSONAR partner, ESnet, developed a Grafana plugin that creates grids like the one that you can see here in this screenshot, that mimics the behavior of the MatDash grid. So with information stored in OpenSearch, we're able to display the same information as you currently have in your MatDash grids and dashboards in Grafana, and then navigate through the different metrics and the different measurements that are available to you. And of course, using Grafana, this enables you also to have more customization. So we will provide you with a default set of dashboards to use, but you're very welcome and actually invited to create your new dashboards that fit your use cases. Another novelty in perfSONAR 5.1 will be the multi-threaded hyper-free that's been developed in ESnet as well, and that will make it easier to test high-capacity link. And this is being done thanks to multi-threading and creating multiple stream of measurement data. I will not go into the details here, but when you will be using this new hyper-free version with the parallel option, you will the run will be the processes will be run on different CPU and different core of the system. So in summary, because I think I'm getting close to the allocated time, what you can expect in 5.1 is the following. A few packages will be removed because replaced by the Grafana user interface. So you will not have MAT- anymore and the perfSONAR graphs. We will change but instead you will have Grafana and all its dashboard. We will change also the OS we perfSONAR run on, and we'll use more up-to-date operating system than the one that are actually supported by perfSONAR 5.0. So you can expect to have EL9. So we're doing our build on Alma 9 actually, but also to have Ubuntu 22, Debian 11, and Debian 12 to be supported by perfSONAR 5.0. And a quick recap of the upcoming new features. So the Grafana UI, for which I show you a few screenshots. The psconfig and the psconfig agent had been rewritten in Python, so you will also have access to that. We will have the threaded hyper-free and two other additions that will be optional installation with 5.1 is a tool that's called MicroDept, and that's been developed in the past by SICT, the Norwegian NREN, that will be integrated with perfSONAR, and the PSGUI, so that's a graphical user interface for doing p-scheduler on-demand measurements from a predefined set of hosts. So instead of running it directly on the CLI, you have a user interface to do it and have easier access to the measurement data. When will it be released? That's a good question. And if you know the perfSONAR development team and the perfSONAR project, you should know that we only release when we think the software is ready, and we usually don't set release date in advance. We will shortly do in a very few months, I think, or in a few weeks, a first beta release that you'll be able to test, and for which we will welcome your feedback. And with this, I think that closes my presentation. Yeah, we'll take the questions at the end of the first part of the workshop, or the presentations in the first part. So I will stop here and will invite Fabio or...
Yeah, I start. Good afternoon, good morning, everyone. I'm Fabio from GARR. Today I will share the stage with Filippo and Alfredo. Our presentation is split in 3 slots. At the very beginning, I will give an overview of what TimeMap is and how it is made. Then Filippo will give an update of a new use case we are starting to support in TimeMap to visualize time and frequency data. And finally, Alfredo will give a recap of what we are working on about anomaly detection. So why TimeMap? TimeMap was born mainly to historicize and analyze latency and jitter measurement to support troubleshooting for very high bandwidth and real-time services. We needed this kind of a different weather map because we all know that traditional weather maps are more focused on bulk transfers and they are a way to understand how the overall capacity is consumed. I think that the best way to introduce the TimeMap approach is starting from a real use case, and TimeMap somehow was born as a side project to Lola, the real-time application for ultra high bandwidth real-time video streaming services for performative arts. And the overall situation is that with Lola, we have a nice setup between Milan, Vienna, and Tallinn. We have different musicians that are trying to set up a distributed performance over the network. And the network engineer from the different NOCs, the campus networks, the NRENs, and GÉANT, set up all the network connections to ensure that latency is stable, and most of all, jitter is stable, because when you're a musician, it's jitter fluctuation that disrupt the experience. So doing the usual active measurements, we see that a given link during the overall path is very nice, a very stable flat line. And then just before the musicians' rehearsals, you see that one link jumps suddenly, and both the latency and jitter spikes. And in this case, it's the network engineer that flatlines and not the measurements. And TimeMap kicks in just to help in understanding what happened, how we can troubleshoot and understand better what is happening under the hood. So how TimeMap has been built? Well, TimeMap decided to leverage agile design patterns based mainly on integration of standard tools, free open source software as usual, by adopting a light footprint custom code approach, mainly integrating what's available, because the objective of TimeMap is analyzing the network, not developing new tools. Rather than a service, TimeMap is the promotion of a methodology in looking at the data. But for the purpose of supporting as most of the community as possible, we decided to integrate in our deployments also support for federated assets through GAIN and a quite rich access control mechanism supporting both multi-tenancy and API tokens. The idea behind TimeMap is that the monitoring tool should adapt dynamically to the changes of the network, so also the configuration is lightweight. The setup in the end is quite simple, because TimeMap is an extract, load, transform application. It relies on telegraph probes close to the network element, and it wraps different kind of probes, mainly written in Python, to talk to the device, supporting the different lengths for latency and measurement collection standards. And then we have a VM that acts as a central collector that runs all the tools that we already know, so Grafana and Influx, plus a thin layer to integrate some presentation and authentication and authorization. And beside the Influx container, we have some additional sidecar containers that takes care of doing machine learning. If you want to have a ride with TimeMap, this is the link for the GÉANT deployment. This is essentially a deployment that the GÉANT NOC uses to keep an eye on what's going on the backbone. But the added value is, of course, in the documentation, the source code. So my suggestion is have a look and see if you can grab something that is useful for you. And just a very quick overview of the look and feel. When you log in, this is the landing page. By holding click, you can access the context menu that allows you to access the actual measurements. Under the hood, we have Grafana, and looking at RTT and jitter, the most interesting thing is that some aspects that are not strictly related to latency and jitter can be observed. For example, in this case, we have periodic events that are not clear, but for sure can have an impact when you need a very, very stable setup. And then you can see things like the effect of rerouting over different kind of circuits, of the effect of rerouting balancing through ECMPs, or again, even weirder things like the effects of clock shifting between adjacent devices. And the effect of our anomaly detection tool is that the points that are considered strange, they are marked with nice yellow dots. So for the support operation, it's easier to understand when the algorithms identify something that is not working as expected. Now I stop. I yield the stage to Filippo, that is going to introduce the new use case. Please, Filippo, let me know when I have to skip the next slide.
Yes. Non mi sentite? Cazzo.
Yes, so Filippo,
Okay.
we can hear you.
Okay. So thank you, Fabio, for the introduction. What Fabio showed you before was the current state of art of the TimeMap graphic user interface. And in this slide, we decided to show you an example of what our updates are implemented. If you can switch slide, Fabio, please. Our first thought was that since TimeMap is supposed to monitor the network state and the network element, we could make more readable this visualization. So we decided to apply a color map to active and inactive nodes, meaning that defining these active and inactive nodes as those nodes which are actually sending measurements, and we can see from the back end. So this is actually not a real-time visualization of the network, but is clearly a mock example. And also, we introduced the possibility to visualize only available nodes, but just hiding the inactive nodes. This we thought it could be much easier to visualize the actual topology. And thank you, Fabio. And also recently, TimeMap was selected to support new use cases. For example, the optical time and frequency network, which from the point of view of a network operator is no different than a data network. So this topology, this different visualization introduces a slightly different approach, since we have different nodes with different functions, basically. So what we did was first define this mock view, and also identify with different shapes, different nodes, keeping basically the functionality introduced for the new TimeMap, the new TimeMap, let's say, functionalities. So we basically can switch between topology with a simple drop-down, and in this slide we can see that by selecting, for example, unavailable nodes and NMIs, we can toggle them. In the next slide, we can see that by simply toggle them, they disappear just as we did for the topology, the new visualization for our TimeMap view. And just one last thing is that since in Grafana 10.1 was introduced geomaps, we're actually thinking to switching between this visualization to a new visualization, actually in Grafana. But this is still a work in progress since we don't actually look into this yet. But we plan to do is the next days. All this visualization is still a work in progress, so there maybe a lot of changes in the near future. And that's it for the graphic user interface updates from my side. And I leave the stage to Alfredo to quickly talk about the anomaly detection.
Yeah, so I'm gonna take it from here and talk about some improvements we have in mind for the anomaly detection engine in TimeMap. Currently, the system has a lightweight anomaly detection module, which employs the Python RiverML library by using a bagging random tree and a support vector machine algorithm. We're able to spot anomalies in the latency and jitter of segments over the observation from the network. The following are some of the opportunities we want to explore to improve TimeMap, making the development of the map to be as reliant as possible on the right tools is a big objective of us, and in an effort to make it more maintainable. So as a first, we want to move most of the data wrangling to the most used tool for data handling, which is Pandas. We also have in mind, you can go to the next slide, Fabio. We also have in mind some improvements for the anomaly detection engine, starting from trying to tackle the classic ML problem of overfitting. We will explore ensembling more models, including some time series classics, such as ARIMA models, in order to try to generalize our anomaly detection better. In such a complicated environment as the networking one, distributions of data are subject to changes, and that reflects on the performance of the anomaly detection models. So we want to introduce more observability of concept drift and data drift by monitoring better model performances and the data distribution parameters. Another big opportunity to explore is not only being able to figure out when an anomaly is on the network is happening, but also when it ends. There's an advanced time series concept, which is called change point detection, which could help us achieve this objective. We want to see if there's anything in that could be useful for our TimeMap project. I want to conclude with an idea of what could be the future of network monitoring projects, just like TimeMap. The IEEE recently closed a call for papers on network digital twins. So we really want to continue keeping our eyes and ears open for any novel promising approaches to network monitoring.
So let me spend a few final words. TimeMap is a quite stable solution right now, and we are working to, as I said, make it easier and easier to adopt and to adapt to the different needs with the focus of supporting mainly new use cases that will come in with the next generation of GÉANT project activities. And of course, the next big thing for us is looking deeper and deeper into machine learning models, moving from a simple way to understand the anomalies and notify the anomalies to something that is closer to an actual modeling and extraction of digital twins for how our networks behave. Thank you all for your time, and I think that the questions are at the end of this session, so I'm going to stop sharing.
Thank you, Fabio, Alfredo, and Filippo. And we can, yes, we'll take the questions at the end of this first session. And I will now hand over to Will for presenting the performance monitoring in the GÉANT network.
Can you see my screen?
Yes, we can see that, yes.
So, yeah, I work in the network management team within GÉANT's Operations Center with a nice wall of screens in front of us. And we're responsible for kind of monitoring the health and status of the network to ensure that it works for the NRENs and the community. As part of our work, we use both perfSONAR and TimeMap and make it available for users to access our servers and use the data we get. I won't go too deeply into TimeMap because I think Fabio has done a wonderful job explaining it to you. So our current perfSONAR server deployment was deployed from early 2020, which in hindsight wasn't the best timing for trying to get servers installed in 10 locations across Europe. When placing them, we tried to ensure that it would offer the kind of best overview of how the network was working for users to access it and look at how our network check network availability and allow users to check whether data transfers would be working well for them. The 12 nodes are split between RNE and LHC1 traffic, and each of our servers has dedicated interfaces for throughput and latency, offering 10 gig performance. We use MadDash for day-to-day monitoring, which in perfSONAR 5 will be changing slightly. And it allows us to have a quick overview of the kind of health of the network and the nodes. In the screenshot given, the Budapest server was down because it is currently being upgraded as we're going over to version 5. And we have regular scheduled tests between each of our nodes. We have latency tests, so you can see any anomalies going across, and it allows community visibility of wider network. And with the ability to change the time frame, you can see if there's any long-term trends or any spikes which need investigating, which can be down to changes of network path or fiber outages across our network. You can run manual tests on our nodes. So if you have users who are complaining about data transfer or throughput, you can check latency manually. And it can be useful if you're doing a network change, you can check it before and after to see if there's any change from the work you've done. And again, you've got the bandwidth graph. You can get up to 10 gig performance. This graph shows from a node in GRNET to our router in London 2, or sorry, our perfSONAR node in London 2. So that could be limited by the perfSONAR node in GRNET, but you can see kind of there's a good flat line of 10 gig, which is going right across the network from Greece through to London. And again, you've got manual bandwidth testing. So this test was done between Vienna and Lisbon and showed over 9 gig throughput consistently throughout the test. We use this normally when we get a ticket in complaint asking about data transfer between institutes. And it can be useful to kind of try and pinpoint any problems. because with the distribution, we can try and choose perfSONAR nodes closest to source and destination as the data transfers. Yeah, we commonly use it for troubleshooting reported throughput issues, which can be verified or narrowed down to institute or trying to eliminate the backbone being the problem. And the connectivity test can be done between NRENs, nodes, or institutions, and we can identify performance variation. And as Fabio said, we have perfSONAR, TimeMap running as well. And you can log in and check the TimeMap readings between our routers, which are, each link is analyzed independently. And yep, RTT and jitter variance over a period of time. Yep, happy to answer any questions at the end of the session.
Yes, okay, good. Thank you, Will. Yeah, we'll do the Q&A session at the end. And now we continue with another GÉANT presenter, Keith, that will explain us more about Brian. And we have some people in the audience saying that they cannot hear well, so I'll be asking the next presenters to speak a bit louder if possible.
Thank you, and yes, I'll try. So for those of you who don't know me, my name is Keith. I am a service manager at GÉANT. I have a background in IP. I'm not a software developer, but I do have quite a lot of experience with network tools. Hence why I guess I'm the product manager for Brian. I sit in the ops team, in the service management team, and I take in requirements from the users. And then work closely with the software development team. So I help to prioritize those requirements. I help to test that sort of thing. So when I arrived in GÉANT in 2017, we used an application, this application up in the top left called Cacti, based on RRD tool. It had a lot of shortfalls, including, but certainly not limited to, the fact that it was built by a subject matter expert, and there were a lot of scripts that only that subject matter expert really knew the intricacies of. And then when he left the business, we were kind of left in a bit of a pickle. It was also an old version of Cacti, and every time we tried to update it, something went wrong and we ended up rolling back. It also rounded data. So anybody who's worked with RRD tool, it's one of the features of RRD tool is that in order to save disk space, which was important kind of 10, 15, 20 years ago, it would average out the data. So the picture you can see here has got 5-minute data points. That's fine. But then once it gets over 24 hours, for every half hour, it takes those 6 data points, produces an average, and that's the only one it saves after 24 hours, and so on and so forth. And so the older you get, some of the data would be averaged out at 1 data point per day. And even if you zoomed in on that data, you'd lost all the rich data. And that was becoming a bit of a problem. Also, everything was very manual. The building of the graphs was generally manual, although we did have some scripts to do it. But if anything went wrong, again, it was manual intervention, and all the aggregates were manual. And I know because I was the mug who had to build them all, and they were very time consuming. And we basically needed a different way of doing things. The initial requirement was for a tool simply to poll the network and save the data. It was given to a junior software developer, kind of to cut his teeth in the business. Didn't really go anywhere. And then back in, I think it was 2018, 2019, I received a call from Eric Reed, inviting me to a meeting, and he showed me this concept that that the software development team had built, that at that point was called Polar. We decided to change the name because it does more than just poll the network. It displays it as well. And I think that it's a good example of what happens when you give these tasks of naming something to technical people. We came up with Brian, Backbone Router Interface Analytics. Here's the Brian architecture. As I said, I'm not a software developer. So if anybody is interested in talking about this in any more detail, I'm probably not the right person. But I can give you an overview of what's going on here. So we have inventory provider that talks to the network elements and the inventory and builds up an accurate picture of the network. Moniker, that's used to classify the interfaces coming from inventory provider. Sensu, which is an off-the-shelf monitoring product. I think lots of people use Sensu. Basically performs SNMP gets on the network. Pushes that output into Telegraph, which is used for collecting and reporting the metrics. Enterprise InfluxDB we have, which is a cluster for InfluxDB, which of course is a time series data store. Capacitor, that processes the batch data that comes in. Grafana Client is a Java utility that automates the creation of dashboards. And then, of course, we have Grafana that displays those dashboards. We built Brian based on a number of principles. The first of which is that it's read-only. So there's no building of dashboards because it's built on a set of rules. So essentially, if you give an interface the right description and put it in the inventory correctly, it will create a panel and put it in the right dashboard. And if no dashboard exists, it will create that dashboard for you. So largely, Brian is fully automated. There are certain exceptions, IT equipment, and some third-party routers for GWS, because we don't hold those in our inventory, nor would we interrogate their interface descriptions. It's high availability. So yes, we paid for an enterprise license for InfluxDB. There's no rounding of data. So all that lovely rich data is kept. We haven't got to the point yet where we do need to archive any of it. I'm sure we will at some point, but we've yet to devise an archiving scheme. We use an agile approach. So I meet with the software developers about every 3 weeks. And we discuss what we're going to do next and then review that. And it's there for everybody. So if you have an SSO login, then you get full Brian. If you don't, or if you don't want to log in, then there is a public version available, which is slightly obfuscated, but most people can get away with just using the public version, although the internet traffic, so the GWS, is only available if you log in. What we've done so far, we've created those 2 different views of Brian, so the public Brian and the one that you need to log into, added the clustered InfluxDB, standardized all those dashboards. We poll third-party devices, as I said. We graph our GWS indirect service, which is via an NREN port, using, we basically tag all the packets coming from our upstreams with DSCP32 and count those on the NREN interface. And then we use destination class usage for the traffic coming from the NREN towards our upstreams. We also graph multicast. We've added errors and discards, multiple new dashboards, third-party access to InfluxDB. We've sorted out. We created a separate instance which we called Robin, which is read-only Brian instance. Another one of those wonderful names that we came up with. We've imported the data from Cacti. And we have actually turned off Cacti now. The next 2 I'm going to go into in a bit more detail. The recording of historic traffic utilization for service and capacity planning work. We started graphing the optical network, And now we use the data that's available in InfluxDB for quite a lot of the service reports. So capacity reports, this was done by our network engineering team for many years, and it was a very, very manual process. I'm sure Rick would tell you how many hours his guys spent on this, so it was quite a high priority. Up in the top left, you've got the actual tool. It's built on Jenkins. You can run the report ad hoc for any time period, and we also email out a report every month. And in the bottom right, you can see an example of one of those reports. It's got the service ID, the host name, description, and the breaches that we need to look at. So the service-based view. So this is based on service IDs, which is basically a perpetual service identifier. So historically, if any service moves interface or router or city, we've lost that data. It's the tool starts graphing the new data, and the old data is nowhere to be seen. And we wanted a way of showing the history of that service. So we came up with the notion of service IDs. We assign service IDs to the top level service. So if there is a lag present, then we will assign it to that, and that's the GA that you can see at this top aggregate, and also a GS for individual services, which you can see here. Where do we go next? Well, we need to fill in the data. So we've got that old cacti data for each service. We also have the new rich data, but there was a gap between the cacti data and when this service-based view went into production or into beta. So we need to fill in that data, a little bit manual, but we're nearly there. And then take that service-based view out of beta to hand over to the NRENs. Further IP6 graphs. So we do have IPv6 graphs, but they can be a little bit cumbersome to get to. So we want to make that a bit more available, a little bit easier to get to. The idea here is that we will actually, add, you can see here, this is actually a drop down under services. Well, we'll just add another drop down in there, which will be services IPv6. Make it a bit more friendly. Create some new dashboards. So we'll put all the ANA stuff on one dashboard, all the IC1 stuff that's coming up on one dashboard, EAP, and basically anything that anybody else wants. Think about what to do with retired services, because if we're going over to a service-based view, when a service is retired, it will no longer be visible. So we need to decide whether we want to make those visible somewhere, what to do with those. We have a request from ROC that sometimes creates separate VLANs for traffic generation, largely to test Ethernet private lines, sub-rate circuits, and that's to use a specific OID on a router on a temporary basis. So not go through the full-blown provision of a circuit, but kind of an ad hoc graph. And then an idea that somebody's had is to use this dashboard to show when interfaces go up and down. Not saying that we will replace our dashboard by any means, but that could be quite interesting. And for anybody who wants to access Brian, so the top URL is the one that you will need an SSO login for. If you do log into that and it gives you an error, you just need to send an email to help@GÉANT.org and say, yeah, I've got a single sign-on. I want to access Brian. And it basically means they just have to put you in the right group in the back-end systems. Or you can just use the public Brian if you want to get a taste of what it looks like using that URL there. And that's me. Thank you very much.
Thank you, Keith. We'll go directly over to the next presenter, which is Nikos.
Hello, everyone. I will present to you WiFiMon, which is a useful tool for Wi-Fi network monitoring. WiFiMon provides various open source tools to monitor performance of Wi-Fi networks, including campus ones. And to do that, we rely on two types of measurements. The one is related to crowdsourcing, which we call it software probes, which include reports of Wi-Fi performance as experienced by end users, roaming, and network. So the idea here is that you can get performance measurements from specific areas in the network which may be not accessible by fixed point probes. However, we complement this approach by using hardware probes, which report performance from fixed locations across the network, therefore complementing crowdsourcing tools and providing a basis for baseline comparisons. In IEEE 802.1x networks, such as eduroam, WiFiMon may provide richer analysis options. For example, it may report throughput per access point, and to do that, you have to incorporate data from radius and DHCP logs. This is optional. The main contributions of WiFiMon is that it measures Wi-Fi performance independently of specific access point vendors. You can serve any vendor that you want and report measurements. It helps detect Wi-Fi throughput degradation, and therefore it enables admins to enhance performance, for example, by installing more access points. And it enables fast distributed control and configuration of hardware probes. First of all, what are the advantages of WiFiMon related to compared to other related monitoring tools? The first thing is that that WiFiMon monitors from the end user perspective. It reports the end user experience by incorporating crowdsourced measurements. The next thing is that it does not require any app installation or end user intervention. For example, you don't have to press a button. Measurements are triggered automatically upon visiting a website. And finally, we enable flexible control and configuration of hardware probes in a distributed fashion. Compared to a very popular tool for measuring throughput, O-class speed test, the differences of WiFiMon is that measurements are triggered automatically when you visit a popular website, let's say. But instead, in O-class speed test, you have to press the button go. The measurements have to be triggered manually. And of course, results in WiFiMon are collected by Wi-Fi administrators, but in O-class speed test are just collected by end users, and the administrator of Wi-Fi network does not get aware of the throughput measurements. In order to operate, WiFiMon relies on four components: the software probes, which is the equivalent for the crowdsourced measurements; the hardware probes, which are the fixed location, the devices reporting throughput from fixed locations; the analysis server, which is like a central corrector, gathering all the measurements and processing them and providing visualizations to the WiFiMon administrator; and the test server, which is a component that is used it includes the code in order to trigger the measurements themselves and calculate the performance metrics. Focusing more on the WiFiMon test server, as I said before, it provides the code and test data for performance measurements. And this component mainly relies on JavaScript technology. This means that we have to embed some script tags in the HTML code of a frequently visited website. And upon visiting this website, the JavaScript technology triggers measurements in automatic fashion. There are two available test tools in WiFiMon, which are popular. These are not developed by WiFiMon. They are developed by popular organizations, the Akamai Boomerang and the LibreSpeed Speed Test. Both of these tools are open source. Another interesting point here is where to place the WiFiMon test server. The WiFiMon test server needs to be placed close to the monitored networks because the round trip time between the end devices and the test server is included in the results. However, even if this is not possible, WiFiMon may capture relative performance changes. And this is the main idea of WiFiMon, not to report absolute values, for example, 1000, but to report the differences and see if the throughput is worse here or better there, and understand why. Delving more into the hardware probes, as I said before, they trigger performance measurements from fixed points across the network, and they complement the crowdsourced ones. The measurements are similar to the crowdsourced. It is the idea that I mentioned before, speed test and boomerang test tools. But we also employ additional data about the monitored ESSID and the nearby SSIDs, such as the signal strength, the link quality, things like that. We have also incorporated measurements from TWAMP, an open source protocol and system data, for example, CPU, memory, disk, and things like that. Of course, measurements in the hardware probes are triggered periodically based on cron tabs. And we have tested Raspberry Pi version 3 and 4. However, any device, any small form factor device that is capable of supporting Unix could do the work. I would like now to report you some measurements from a recent pilot that WiFiMon had in Yerevan, Armenia. This was the third WiFiMon pilot. The first one was in TNC 19, and the other one in the GÉANT Symposium 2020. And during this pilot, we monitored EDROM at the Institute of Informatics and Automation Problems, IIAP, in the National Academy of Science of Armenia. The duration of the pilot was around 15 days. It took place in autumn 2023, and we monitored about 100 people. There was also a conference at these days. This was the main idea, that we had to monitor the spectators or the audience of the conference. And we incorporated measurements from one hardware probe, a Raspberry Pi 4 model device. The goals of the pilot were to experiment with newly introduced WiFiMon features and help the Wi-Fi administrators of the IAP organization to identify interesting points that require further inspection. These are some images from based on this pilot. I would like to also show you the WiFiMon user interface. This is the overview tab, which summarizes received measurements on a daily basis. You can see that it's the total count of measurements, the average value of download throughput, upload throughput, things like that. And here are some visualizations. This particular visualization is the average upload throughput reported for, I think, 10 days. Yes, 10 days. And you can see that here we have aggregated all test tools. Both Boomerang and LibreSpeed values are here in the chart. And as you can see, there are some visible drops there. For example, in the 25th, in the 29th to 30th, and on 3rd and 4th of October. These are some helpful insights that were provided to the Wi-Fi administrators, and they could take a look in order to see if they can see something in their logs and help themselves. In the next slide, I depict the average jitter during the last 10 days. You can see that with the blue circle, we report a very high jitter value. And you can see that this jitter value matches the average link quality that's reported from the hardware probe wireless network interface card. However, you can see that these measurements, which are derived from the wireless network interface card, do not have nothing to do with the values reported from the upload throughput. You can see here that we have a lot of performance drops. However, here, from the wireless network interface card, we only get one major drop. This means that the tools provided by WiFiMon may help administrators in order to complement the values received from the wireless network interface card. Another very useful visualization is this one, where you can see the average number of Wi-Fi users present in the Wi-Fi network. This is a very experimental tool, and it is reported by the ARPScan Linux utility. We can see that there are no users during the weekend. This is the blue rectangle, but we can see a high number of users on October 3rd and October 4th, the green rectangle, when there was a conference that I mentioned before. Now, the installation of WiFiMon is fully automated through an Ansible playbook that installs both the WiFiMon analysis server and the WiFiMon test server. The duration of this automated installation varies based on the Wi-Fi throughput available, but it is around 15 to 20 minutes. Everything is automated in WiFiMon. Manual installation has been abandoned because it was very time exhausting. Now, I would like to mention a very nice feature of WiFiMon that has to do with that facilitates the control of hardware probes. The old approach of WiFiMon that we followed until recently reported some limitations. In order to configure a hardware probe, you had to go there with your monitor, connect your monitor, your keyboard, your mouse, and insert details on, for example, connect to the Wi-Fi network, troubleshoot, insert details in configuration files. and this was very time consuming, and it was very difficult for NAT networks and for large-scale setups. Also, the manual editing configuration files proved hard and error-prone. Therefore, we introduced a novel approach to facilitate the distributed configuration control. And now you can control and configure probes from a centralized point, the Wi-Fi analysis server, and there is flexibility provided for configuring and controlling probes behind NAT networks. This is made possible using a configuration tool that is pretty much similar to the ideas of Ansible, and it is called SALT. The main idea that we preferred SALT instead of Ansible is that SALT establishes application layer communication, something similar to TeamViewer. And this enables us to remotely configure probes from the Wi-Fi analysis server, but the configuration is easier behind NAT networks. Instead of relying on IP addresses, it relies on application layer details, like TeamViewer, for example, in order to therefore enable you to find probes behind NAT networks. Therefore, public IP addresses are no longer required, and IP space is conserved. Another very nice feature is that SALT includes a PubSub method broker, a queue that's called 0MQ, which enables the parallel configuration regardless of the number of probes. Even if you have 10 or 1,000 probes, theoretically you can do the configuration in parallel. And finally, in order to abandon the manual configuration of files, we used some Jinja 2 templates that are filled through that the Wi-Fi administrator is required to fill the details in a configuration page, and everything is translated and transferred from the Wi-Fi analysis server to the probes. Finally, we are trying to do so. We had the problem that WiFiMon feedback is manual. For example, you have to inspect the dashboards and try to do things yourself to reach some conclusions. Therefore, we are currently trying to incorporate some basic anomaly detection. And the new version of WiFiMon, which has been published in the previous month, 2.2.0, introduces such a mechanism for automated time series analysis. We are using a mathematical method that's called Hampel, but the main idea is extremely simple. It monitors a median value, and it tries to assess deviations from this median value during specific time windows. This is, of course, still under improvement, but you can see some results here. You can see that the red dots indicate the points that should be further inspected. And I know there are a lot of points. If you want to be stricter, you can include stricter parameters and focus on the most important points. However, in the future, we have to also include an alert-based system in order to take the timestamps of these red dots and incorporate them in a dashboard or in our user interface. This is our next step. Thank you.
Thank you, Nikos, for your presentation. This brings us to the end of the presentation of this first part of the workshop and gives us time for some question and answer. So some of you have already sent question in the chat, and those are getting answered in the chat. But if you want to ask your question directly here on the video Zoom room, please do so. So I think there was a question in the chat that was not answered yet from Christopher Walker. And that's probably a question for Keith about the access to Brian. So if one wants to try to connect to Brian, can it do so with any federated identity from Research and Education Network? Or
yes, should be able to.
Okay.
Certainly any EU establishment, yeah.
I've just tried with my GIST federated identity and it doesn't work. So we can perhaps sort it out offline.
Well, so all that means is in the back end, you are not associated with a group. So if you can just drop a mail to help@géant.org and just say, yeah, just try to log into Brian. Can you do the back end for me, basically? They'll sort you out. And if you've still got a problem, Christopher, let me know and I'll sort it out. Yeah, I see the question just come in from Kurt about streaming telemetry. So we have tried streaming telemetry in the past, and it went horribly wrong using Juniper. As you'll know, we're switching to Nokia. So I have no doubt that we will try that again with Nokia and hopefully it will go a bit better.
I can give you a little bit more detail about what went wrong with Juniper. The way that Juniper implemented streaming telemetry, it creates a call to root login every time it streams something out, and it's unsuppressible. So with that, when we turned on streaming telemetry to use with Brian, it absolutely clobbered our Splunk instance with rubbish data that we couldn't suppress. So it all worked fine until it didn't. So it broke Splunk by exceeding our license. And with that, we said, hey, Juniper, fix this. And they went, nah. So we had to turn it back off. And as Keith said quite correctly, it'll be a day 2 project to see if it works correctly with the Nokia.
Thanks, Rick.
Another Brian question, maybe for you again.
Yeah, maybe one day. It's on the list.
Yeah, I mean, I really like Brian in that there's a lot that's public and you can look at it. It would just be lovely to be able to sort of visually see all those links rather than drilling down through the menus. I think what's there is great, but it's just
I agree,
it'd
Tim.
be nice to be able to see. But
yeah, I agree. It's just not particularly easy, and we have a big long list of requirements, but we will get to it eventually.
Great.
There was also a question from Robert. Do you want to ask it here on the video?
Well, yes, my question is on thinking on perfSONAR and TimeMap coexistence on the same measurement platform, hardware platform that we are already installed in our backbone. So what additional software or hardware measurement points or software instances do we need in the backbone in addition to perfSONAR to have TimeMap integrated as well as a performance measurement and troubleshooting tool?
Maybe I can answer. Indeed, we started discussing with Lætitia about the chance of having TimeMap and perfSONARs talk each other, but then the time was not enough to tackle this on a more practical basis. I think, but I'm not familiar enough with personal internals, so please consider that my information could be partial. I think that once you have installed an influx database over a perfSONAR node and you have a telegraph probe telegraph agent that can be used to query your devices, I think that the two software could coexist quite well. As I said, the TimeMap does not come as a ready-to-use tool, but it's more meant as a solution, as a promotion of an approach. So we do not have ready-to-consume recipes also in the documentation, because that was not our goal. From the very beginning, we wanted to focus in understanding how the network behave and the model we can build on top of the data that TimeMap as a tool gets from the network. But I think that this kind of mix and match could be done in a not too hard way.
Okay. Well, yes, understand. So what I understand is there is no package that I can just use and install it on an already operational PerSONAR measurement point or PerSONAR measurement archive. So yeah, okay.
Right now, no.
Clarify it a bit though. I mean, so Robert, there is this thing that it depends. So it's not clear from your question on which level. For example, TimeMap uses agents to poll the routers, the network appliances, while perfSONAR initiates the measurements on its own servers and then generates the data and pushes to a measurement archive. So one approach would be most likely, I'm not sure if where you're aiming at, but one approach could be like polling the perfSONAR servers as well for their latency measurements and putting the data into TimeMap. Or another approach would be kind of to look into an integration of the measurement visualization, you see. But so that's two different ways to go. And it really depends on where you are aiming at.
Well, I just like to have, in addition to the perfSONAR one-way delay measurements that we already are having, measurements done using the TimeMap approach. So I understand that TimeMap is capable to use the software that is running already on the routers, the TWAMP agents that can be deployed there, and using, for instance, that one and the additional capabilities that TimeMap provides in addition to perfSONAR one-way delay measurements can be used. The question is, how can we do that in practice? What do we need to do on our hardware or software instances to do that? Are there packages that we can deploy, simply not develop, but deploy?
Yes, I understand. So, but with the wording packages to deploy and so on, kind of it gets a bit confusing, in my opinion. The thing is, the thing that I really hear from you here is that you're interested in a system that correlates the measurements, that you can see these measurements and the other measurements in the same system. So it's not needed, to have packages integration. All you're looking for is to have the visualization and the measurement data somehow together. Did I get it correctly?
The last sentence that you said, it is sufficient for me if we can run it on different GUIs, for instance. Just what we wanted to have is we do not want to install additional hardware or additional time-consuming software to maintain.
I see your point now. Okay. Yes. Well, the thing is that perfSONAR uses the measurement archive, the perfSONAR measurement archive, which is based on Elastic, and TimeMap is using InfluxDB. So at this point in time, since both of these are time series databases, most likely it will be possible, but not out of the box, I would say. I'm not sure.
I could probably speak a little more to that. Yeah. So just it's kind of two topics piqued my interest. One is sharing with perfSONAR on the same machine. That's absolutely okay. You have to kind of strike a balance between not chewing up large enough amounts of additional processor and other resources that your measurements get distorted. Although on modern hardware, there's usually plenty of network interfaces and plenty of CPU to go around, depending on what you have, obviously. And as far as getting the information, getting the measurements out elsewhere, pScheduler has a whole bunch of different archiving options. One of which is an HTTP archiver. So if you wanted to send the measurement results someplace other than where we send them by default, you can pretty much anything that has an HTTP interface can receive those measurements, and it's really just a matter of configuration. Additionally, there's a it's not really a hidden feature, we just don't talk about it much. There is a way to have a perfSONAR node archive all of its measurements someplace, whether or not they were specified. So if you kind of want to skim those off and send them someplace else, you have that option as well.
Okay, at least I have a bit of an impression how we can do that, but well, I'm not sure. What I understand is that if we want to install somehow a TimeMap installation, we have to develop ourselves some stuff. That is my understanding right now.
Yeah, most of the central facility can be get from the repository. Also, the good portion of the probes can be acquired as is, but for what it relates to the actual Python script that probes the devices and the presentation layer, you need to adapt it to your backbone because, of course, the topology is different from the GÉANT 1 or the GARR 1. And the probing solution, as discussed in the chat, strongly relates to the platforms you use. Of course, if you are using Juniper, everything is essentially ready to go. But if you have Nokia or Cisco, then something must be adapted and tweaked to get a T1 from the OIDs of the SNMP or GNMI that you are going to use.
Okay, thanks for all that input. Thank you.
Thank you. There was also a question in the chat from Daniel asking about layer 2 monitoring. Is there someone in the audience that want to answer that, contribute that about layer 2 monitoring? I don't think the software we presented that was presented today is taking charge of layer 2 monitoring.
Except for Brian, I would say.
Yeah, I think the challenge with layer 2 monitoring is that typically they have their own management system rather than SNMP. And although we have some layer 2 data in Brian, it does come from the management system, not directly from the devices. So I think at the minute it's quite limited, and it's only 15-minute data points rather than 5 minutes. And I don't think we'd want to pump it up any further than that. It's yeah, I think it's an age-old problem.
Right, good. Is there some other questions about this first part of the workshop? If not, then I think we can take a break. So we had scheduled about an hour break now, and to resume with the second part of the workshop at 1:45 UTC time. So that's 2:45 for people in the Central European time zone. And then we'll have presentation about NetSage from the global NOC, from ESnet, Internet2, and RNP. So you can stay on the Zoom room or reconnect later. It's up to you. And we already have presentation uploaded to the events page if you want to to check and review those again. So the nearly all presentation that happened in this first part of the workshop are posted to the events page already. Thank you all, and see you in about an hour. All right, so welcome back, everyone. I think we're ready for the second part of this workshop. That will be about NetSage, the global NOC troubleshooter, and then performance monitoring in ESnet and personal deployments in NetUA and RNP. And if Doug is ready, I will hand over to him for the NetSage community update.
All right, thank you, Lætitia. Appreciate it. Okay, so appreciate the time this morning to talk about NetSage and just some of the development that we have going on here at TAC. So for people who are not aware of what NetSage is, it basically was a project that was originally NSF funded between Indiana University, LBNL, and University of Hawaii to visualize flow data for mainly IRNC links. So we were looking at links that the international networks at IU hosts that go over the near links, the now near 3 links, and transpac links. And so eventually that kind of blossomed into a larger collaboration with R&E regionals and other supercomputing centers to gather their flow data as well. And the idea was to take network data that typically is not easy to visualize for the average user and give them access to it. As network admins and sysapps, we have the ability to look at this data all the time, but what if you're a researcher, or maybe you're a decision maker higher up the chain and you don't have your hands in the systems every day? So we built NetSage a little bit differently than a normal type of tool that you would use for flow data, and we decided to base it around answering questions. So as we looked at the flow data and said, if you had this data and if you were a user curious about what this data was useful for, what kind of questions would you ask about it if you knew it was network related? So a lot of those came about as, okay, well, who's doing a lot of data movement in and out of my organization, or what countries am I sharing data with, or if there's a specific project, how much data is flowing for that type of project. So we built it around questions so that there'd be these human readable summaries of what your network traffic looks like that you could use for a variety of things. You could use it for network analysis, that kind of work, but you could also use it for understanding who your big data partners are if you're, for instance, looking for a CC Star grant or some sort of, grant from any educational institution out there. And you need to justify, why you would need that money because you're moving large amounts of data. So the questions that come up are usually ones that they're kind of patterns that look a little bit odd. For instance, if you were looking at SNMP data and you saw this kind of regular pattern, maybe you're interested in why that pattern occurred at that specific time frame and no other time frame. Now you can dig in a little bit deeper since you've been able to see what happened. Maybe it's nothing. Maybe it's something you expected, but maybe it's something interesting that you need to be aware of on your network. Sometimes we even catch kind of routing mishaps. This one happened to be a transfer between Singapore and Taiwan that came through a router in Los Angeles. So crisscrossing the Pacific twice to get between 2 Asian countries is obviously not the most efficient way to do things. So occasionally we see interesting routing problems pop up when we look at the flow data. And sometimes it's just a simple question of, we do a fair amount of transfers, but why are they so slow on average? 2.7 terabytes at an average of 4.6 megabits. That's a long wait for that data to get from A to B. So again, just being able to present this data in a very easy visual format that allows you to ask questions about the data. And that's really what NetSage is for. So you can start with just basic dashboards and look at your top sources and destinations, that sort of thing, and who's accessing your data or where you're sending a lot of data. And then you can dig deeper and you can visualize down to an individual flow level between two institutions, or look a little bit more at performance of individual flows. If you're doing multi-threaded transfers, are some of those performing well and other ones performing slowly? Do you have a bottleneck somewhere? So data privacy, of course, is of concern to all of us. So NetSage only keeps data on flows over 10 megabytes for any kind of circuit, or 1 megabyte for an archive. So that eliminates your DNS traffic and emails and other small things that we're not interested in. We're really looking at the large flows. We don't collect any PII. We remove the last octet from the IP address. So NetSage never, under any circumstance, stores full IP addresses. And so we have a full privacy policy out there. Again, because NetSage was built to be a publicly consumed product. We don't hide these behind passwords. We don't try and obscure the data. We just make sure that as we present it, that we're doing it in a way that's sensitive to privacy. So that process looks a little bit like this. There used to be a couple of methods for ingesting data to NetSage, and we've normalized this to a data ingest pipeline that it runs as a series of Docker containers, and that happens all at your site. So everything kind of to the left of the ingest pipeline there happens at your site. You're getting SNMP or flow data or tstat data or perfSONAR data, any kind of data like that that we can digest, basically gets run through this data ingest pipeline here, where we do some of the things we talked about earlier. We throw away those flows that are 10 megs or less. We stitch long durations flows that are longer than 5 minutes together. We do tagging, GeoIP tagging. We do science registry tagging, which we'll talk about in a second. And then we de-identify that data. That's where we take that last octet off of the IP address. And then that all gets shipped to TAC, where we store the data in an elastic archive. There used to be a couple different archives for this kind of data, and again, that's all been normalized. Everything's elastic now. And then there's Grafana performance dashboards that show you the results of that. The science registry is a way that we can be a little more specific about how we tag this data. If we do a GeoIP lookup, it's probably going to come back as just your institution. So if your institution has, you know, a large amount of IP v4 or v6 space, then it doesn't really tell us a lot about what that data might be. But through user contributions, we maintain a science registry that says, well, we know this specific IP address is a scientific instrument or a DTN or a compute cluster, or this range of IPs represents one of those things. So currently we match by IP only, although as some of you are likely aware, there's a packet marking initiative that's tied in with the LHC1 group to identify flows a little more directly by doing fireflies with IPv4, which are kind of a packet that runs alongside to identify what that flow is, or in IPv6 space, can we put those extra bits in the header to positively identify what kind of traffic it is? And we're looking at ways that we can ingest that into NetSage. But basically, think of this as just kind of a more specific database for what the resources are, so that we can tag them with some specificity, even though, again, we're de-identifying that last octet. So some of the updates that we have, we had to make a pretty big overhaul. This is a very, very early look. We're working on this currently, and we're hoping to have a release out by early March at this point, which will be our NetSage 2.1 release. And the big push for this release is Grafana 10. So prior to this, if you've used NetSage at all, you'll notice up here in the corner, this little guy, we called it the spinny S up here, was the navigation source. And when you clicked on that, it would drop down a set of questions that, you know, that we talked about earlier, and that would allow you to navigate through NetSage. So the the change here really came about because Grafana kind of changed the way they started doing business. And they said, look, we really, really, really want you to embrace the way Grafana is presenting data and the way Grafana does navigation. And so several of their changes actually broke our NetSage navigation plugin in very specific ways. And moving forward, we realized that the way we had done navigation in Grafana was not going to be sustainable. So we've kind of retooled everything so that it now meshes with the way Grafana is trying to move forward. You can see there's the breadcrumb, what they call breadcrumb navigation up here that allows you to move back and forth between dashboards. We're going to be integrating a landing page, which is something we've never had before. When you went to a specific NetSage instance, you would just land directly on a flow data or an SNMP page, depending on what kind of data you were collecting. Now there'll be a home page that, worst case scenario, if you go over here and click on home, it's going to take you right back to this landing page in case you get mixed up in the navigation there. So it'll be very familiar in a lot of ways. The questions will still be there. The navigation should be very similar, but it's going to be more closely aligned with Grafana's methodology for navigation, and as opposed to us trying to make it our own. So a couple other things that we are working on is NetSage for Access CI. This is up and going right now. So this basically is a set of one set of dashboards for all the Access CI compute resources. The NSF has said they've had some interest in being able to visualize this data a little bit better. So right now we have TAC and where I'm at, and then the Pittsburgh Supercomputing Center are online contributing flow data. And San Diego and NCSA and others are coming soon. We're basically working on getting them online, and so they've got some problems that they're solving on their end so we can filter out the data that they want to give us. But those very, very soon, in the next 2 to 3 months, we should have them all online. So that's currently available at access.netsage.io. And so again, this kind of gives a little more insight into actual supercomputing resources, compute resources, and the kind of data that's flowing in and out and where they're doing a lot of transfers with. So right now it's just flow data. We've got in-band telemetry that we're currently working on at TAC. That may be something that we look at for this dashboard as well, because it would give us a little more specificity with the data we're collecting as opposed to just, say, SNMP. But currently they're just contributing flow data, and for the immediate future, that's how that's going to look. And kind of tied in with that, as we're interested in more and more specific data about transfers, is NetSage actually has the ability to ingest Globus data now. So Globus came to us and said, if we gave you 1.5 years of data, what would you be able to do with that? And we said, well, let's take a look at it. So they shipped us a 5.7 million line CSV file full of Globus tasks. So these were complete transfers to and from different locations. And so we came up with the ability to run those through a modified pipeline and still do the de-identification. There's no IP addresses in there. There's nothing identifiable, but you can now look at Globus data the way that you would look at regular flow data. And so this could be from the Globus mothership, as we call it, the Globus archives at the central office there, or your own logs on site. In fact, I'm going to let me bring this back a little bit. And if I go over here to Globus tasks, this is data from TAC. I know it says the last 2 years, but really it's just the last couple days. So this is actually not flow data. These are completed Globus tasks to and from TAC. So unsurprisingly, if you know where TAC is, it's part of UT Austin. That's where a lot of our business is being done. But you can see San Diego, Oak Ridge, Pittsburgh, University of Minnesota, NERSC. There's a couple other places on here that we would regularly do business with. And so unsurprisingly, they show up here in NetSage. So it has that same NetSage look and feel, but with the ability to look at Globus tasks now. And then earlier we talked about the access dashboard. Again, this one's publicly available now. So if you want to take a look at access data from TAC and PSC, this is all flow data that's publicly available, and we'll be adding the other access CI resources here in the coming months. I think I'm pretty much right up against my time, so I'll stop my share and hand it back.
Thank you, Doug. As we did in the first part of the workshop, we'll take questions at the end of the second part. So I will now hand over to the next presenter, which is Luke from the Global NOC.
Thanks, Lætitia. So we've been focused on network automation at Global NOC for the last few years. And as we started maturing our systems for automatically configuring networks, we started looking at what we could do to bring automation to the operational aspects of our organization as well. And so one tool that we developed I'm going to talk about today to help with that, we're calling the Global NOC Network Troubleshooter. And so we ask these set of questions to think about how we might be able to take some of the automation systems we developed for configuration and bring them to our network engineers and our service desk technicians as they are troubleshooting incidents or performing change maintenances. So some of these questions were things like, how can we better support our engineers to resolve incidents more quickly and more effectively? How can we get the right set of diagnostic data in front of the engineers quickly so that as they're trying to solve those problems, they have all the data they need to do that? Can we provide guided troubleshooting for individual incident types? So maybe things that needed to go to our on-call engineers overnight with a little bit of automation could be handled by our Tier 1 service desk technicians without having to wake anybody up in the middle of the night. And can we even do some things to automatically remediate incidents as we move to bringing more data and automation into the incident handling process? So where we started was gathering a bunch of data from different systems and putting them into incident tickets. This got some data right in front of the assignee for that ticket to help them troubleshoot and resolve that incident. But as we started doing more and more of this, we found that it kind of got cluttered in the ticket, and maybe sticking this data into the ticketing system wasn't sort of the best user experience for our users. So we thought a little bit about how to take that same set of data and refactor the user experience to make it a little bit better for folks. And so we ended up with this idea of providing incident-specific troubleshooting dashboards, where if you get a new incident, and that incident may be composed of several different alarms that we've detected, how can we take all that data and present it to you in an easy-to-use dashboard to help you get all the data you need to resolve your incident? So this is sort of the set of things as we started thinking about those dashboards that we wanted to make sure we included. We have a lot of different operational monitoring systems at Global NOC. It's sort of centered in our ticketing system and a big board system we have called AlertMon that ties all the alarms to the tickets. And so we want to integrate that ticketing system and that monitoring and alerting system together in these dashboards in some cohesive way and leverage the automation systems that we'd already deployed at Global NOC. The basic set of things we need to do is, when a new incident is detected, we need to analyze the alarms related to that incident, maybe run a set of commands at real time to gather some data, and maybe pull some data from our existing measurement monitoring systems and sort of put it together for the users. So we have a variety of systems that store time series data. We've talked a lot about perfSONAR today. That's something we use heavily at Global NOC. We have a time series system that we call Snap that can store data from SNMP and NetFlow data sources, streaming telemetry as well. And that all sort of sits in a set of archives. How can we pull all this data together in a single pane of glass related to a particular incident? So on the right, sort of a little storyboard we started with for what we might want this to look like. But we knew we had to combine some components we already had today and add some new components to make this a reality. We ended up storing a bunch of data in a MongoDB non-relational data store with a web service on top, and then integrated with some of our existing tools like the AWX and Ansible system that we're using for network automation systems. We figured we could use the same system to sort of fetch data from the network at incident or change time and store them for analysis by our engineers. At the same time, we were investigating some new technologies at GlobalNock for both our user interface and our backends, as well as how we deploy things. And so you can see some of the technologies that we were beginning to play with here, Fast API and Python on the back end, React in a layer we built on top called GNUI on the front end, and deploying tools like AWX in a Kubernetes cluster. And so it was sort of a good opportunity as we were building this new tool to sort of experiment with some of these new technologies. And so this is sort of the architecture which the tool I'll be showing is built on. So what's the entry point in this tool for our users? So, you know, oftentimes when an incident is created or a new change record is created, the ticket is sort of the hub of the data for that. And so an engineer or a service desk technician will often be in a ticket when they need to start looking at an incident or change. So we created a really easy menu item in ServiceNow where when they're in that incident or change record, they can click this Open Network Troubleshooter task, and it'll take them to this new dashboard I mentioned that's sort of specific to their incident that sort of can help guide them in troubleshooting and resolution. This is a real high level of what that dashboard looks like. I've sort of cut off the top here, but if I included the very top, you would probably instantly recognize that we're using Grafana to create these dashboards. We've sort of standardized on Grafana for most of our time series data interfaces. So what does this look like? The first thing you're going to see here is a brief overview of the incident. Is it currently active or not? This is a particular incident on the Internet 2 network that has a few different alarms associated with it. In this case, it's an incident related to some BGP peers that went down, and it includes both IPv4 and IPv6 peering sessions. Right at the top here, the engineer can see that this incident is still active and when it started. Scrolling down the page a little bit, we do some, at the time the incident is detected, we'll go out and run some pings to verify our layer 1 and layer 2 connectivity, and also see if this might be an MTU problem. So we're sending pings at various sizes. You can see in this case, we've seen that the pings have returned data, and so maybe it's not a layer 2 issue, although I'm not sure what to think of the fact that only some of the large size packets went through. Scrolling down a little bit more, we gather log data from the routers involved, and not just all of the recent log data, but log data that we think is relevant to this particular incident. So we're looking for any logs related to the BGP sessions that have been alarming here. You can see in this case that we've had a hold timer expired, and so that might give the engineer some clue about what might be going on here. We also log into the router and do a show route to get that data and present it to the engineer. In addition, we'll show the commit history. So what's been going on this router recently? Has there been a change committed to the device that might be contributing to this incident? We pull in some time series data. This is a graph of the interface that these BGP sessions that are alarming ride over. So you may be able to do things like see, has this interface recently been taking an increasing rate of errors that might be contributing to this outage. We also get logs directly from the device to determine up and down times for the event. And so maybe this is something that has flapped 2 or 3 times. We can put that data right in front of the engineer and show them exactly when all of the times this event occurred was, and so they can correlate those times with other data like the time series data or the commit data. So that was sort of our first foray. As we started developing that, we got some questions about, hey, could this be useful for change events as well? And so we've been enhancing the tool to create a set of change dashboards that allow people that are doing scheduled maintenances to get the same type of support and data related to their maintenance. This maintenance I'm showing here is related to a couple of routers on the Internet 2 network. The engineer at the top gets sort of a quick overview of the maintenance. When is it supposed to start and end? How much time do I have left in my maintenance window before I'm supposed to be done? What are all the nodes that are affected? Scrolling down the page a little bit, if this incident or if this change is creating any active alarms, the engineer will see those alarms. You can actually click that little View Alarms and Troubleshooter button and see the same type of dashboard that we saw in the last set of screenshots for the alarms related to the maintenance. So maybe those alarms, maybe you get some additional alarms that you were not expecting as part of your maintenance. You can view those in the Troubleshooter and get more details. Hopefully at the end of your maintenance window, when you're ready to close it out, you can click that End Maintenance button at the top to do it. But hopefully when you do that, that active alarms panel shows empty, so you can verify that any alarms you created during your maintenance have gone away and sort of the network looks healthy. In that same line, we also do some additional checks to look at the state of your network before the maintenance and the state after the maintenance. So we have a couple of the routers that were involved in this maintenance, and we're collecting some data before the maintenance starts, things like what interfaces are up, what BGP peers are up, and we can customize that per maintenance type. And then after the maintenance is done, or while you're working on the maintenance, you can look at that same data again and see, after I've done my work, are the same set of interfaces up on the device? Are the same set of BGP peers up on the device? Or is something still down that I wasn't expecting? Sort of gives you a quick red light, green light to let you know if, at least at a basic level, the things that were working before your maintenance are still working after. We've also added what we call ad hoc mode to this. So sometimes you don't have an active alarm, you don't have an active maintenance, but you want to see the same set of data for a BGP session or interface or some other object on your network as if it were alarming. Gather that same set of data, maybe prepare for a maintenance, or maybe in reaction to a customer calling in and say, I think I'm having a problem, but we don't actually see an alarm on the board. We may need to investigate that same set of data as if there were an alarm detected incident, in this ad hoc mode lets you see that same data for any piece of your network. So what's next? One of the things that I mentioned at the beginning of the talk that we've been focusing a lot on now is how we can take this tool from something that is focused for our network engineers to use to be a support tool in the future for our service desk technicians to allow them to handle more issues without having to hand it off to an engineer for resolution. There are a couple of different use cases we're looking at here. One that we get commonly on small end user sites is what we call the site down scenario, where a site, maybe it's multi-homed, maybe sometimes it's not, it's gone down, and we're trying to figure out why. It might be because of a power outage. It might be because of all of their WAN connectivity has gone away. Can we do things in the troubleshooter to look at all of the data that we have about the network to make that determination proactively and say, hey, this scenario, it looks like a power outage. Our first step should be to contact the site and verify they still have power. Or, this really doesn't look like a power outage. We're pretty sure the site still has power. Maybe we can reach it via an out-of-band connection, but it looks like their WAN connectivity is down. We need to sort of start the path investigating in that direction. And that's something that often requires an engineer to diagnose today, but if we can provide this tooling in the network troubleshooter, we can allow our service desks to do that without engaging those engineers. Similar set of scenarios we're looking at for our service desks to be able to handle more fiber outage and maintenance events. Things like automatic correlation of light levels before and after an event, comparing that to baseline data that's stored in the optical system to know, for instance, after a fiber cut has happened and that fiber has been repaired, how do the light levels compare to the baseline light levels? Do we think this repair looks good? Or maybe did the system come back up, but the light levels have gone down more than we'd expect after a restoration from a fiber cut? So maybe we have a bad splice somewhere that we need to investigate. Bringing some automation to that, allowing us to not miss those type of events and allow those to be handled at our service desk level. The general thing that we're sort of shooting for here is to provide runbooks for our service desk that have all this rich automation embedded into them. So when they get one of these events, not only do they have the process right in front of them for how they handle this event, but they have all the data in one place to allow them to run through that process effectively, quickly, and accurately. So in closing, this is sort of what the philosophy we're operating under here is robots and humans working together can make our networks better. So thanks for the time today.
Thank you, Luke. Right on time. And so we can continue with the next presentation from Andy Lake from ESnet.
All right. So hopefully everybody can see that. So hi everyone, I'm Andy Lake. I'm from ESnet. I know a lot of you. So I'm going to be talking about kind of performance measurement and monitoring at ESnet. We've got a lot of things going on, so I'm going to kind of take a broad view of things, but obviously in the Q&A session, I'm happy to drill down on any of these. You'll also see some common themes with some of the other presentations, which I think is cool. So to kind of hop into that, just to kind of scope things a little bit at ESnet. So we do a bunch of measurement, and kind of our philosophy is, or the way we like to think of things is, we're trying to tell stories with the data, right? So we want to basically be able to zoom in and zoom out depending on what we're trying to do with the data we collect. So obviously there's operational type things, right? If the network's broken or something's going on with a transatlantic circuit or whatever, we want to be able to debug that. There's also engineering type things we want to do. We want to be able to forecast out, are we going to have enough capacity where we need it, things like that. There's also a lot of engagement with the community in terms of like things like the data challenge, the LHC data challenge that are going on right now. Want to be able to create views of the data, so those communities can basically determine are they getting the performance they need, at least out of the ESnet piece, right? And compare to their own data. And then there's the really high level stuff, right? Probably all of us have benefactors in some form, right? So when we need to do annual reports or, talk to Congress or things like that, we want to be able to do nice visuals that kind of at a high level can show all the great things that we're doing, right? So we have a lot of use cases, and it's not just basically about the numbers, right? You need to contextualize the numbers that you collect and make them useful. And if this slide seems very similar to like the question slide that like Doug presented when he talked NetSage, there is a shared history there. So that you'll probably see some common themes kind of running throughout. So I think a kind of a turning point for measurement at ESnet was back around 2020, which is around 3 years now. We had a few measurement services. Some were commercial offerings that we were kind of end of life. We needed to replace like an old flow system. We had an SMP collection system that was in-house that we weren't particularly happy with. So basically we kind of built this group to take a more holistic view of measurement and kind of set a vision for what ideally it'd look like. We had a few tactical things at the time, like I mentioned, the flow system. So we did some comparisons with kind of commercial products. Yes, I was involved in the NetSage project at that point. So we looked at that as well and actually came up with a solution that used kind of the NetSage approach in terms of how we monitor the network, and have kind of built it out from there, right? And so I'll kind of get into what exactly that looks like, because there's a lot of pieces. So we actually have a team, mostly software developers, kind of dedicated to measurement and analysis at ESnet. And so we have a bunch of different projects that we work on. Either kind of writing code or just kind of maintaining the infrastructure or both. And so kind of our big ones that have been around at least for a few years are listed here. So if you've ever been to my.es.net, that's kind of our portal. That's the window into all our data. Stardust, which I'll talk a lot more about, is kind of a big umbrella, and that's where we kind of collect all our different types of data. And it also has a visualization component based on Grafana. And it really kind of encompasses a good chunk of what we do. We work actively both as developers on the perfSONAR project, as well as we have a deployment within ESnet. Basically at every router, we have a perfSONAR node. We're also the main developers of iPerf3, which is probably, in terms of user base, our biggest software project. And most recently it came out with threaded version, which has been really handy. We even had an instance last week, we were debugging with Fermilab, and basically because we had perfSONAR nodes in the right places with 100 gig interfaces, and we could basically run iPerf3, and we had to basically get up to around 400 gigs to debug the problem, because the problem was they were capping at 200, and we were able to do that, between multiple hosts, obviously, which is really cool. So, and then there's a couple of kind of newer things that we're working on. Some of these are still in development. Some are high touch is almost kind of probably belongs in that first slide, but basically you may have heard Yatish Kumar from ESnet talk about that a little bit in the past, but basically we've got these FPGAs in servers at all the routers and getting mirrored traffic, and can do essentially like Wireshark at each router essentially, and then do kind of cool analysis with it. We have a project called FunCap, which is like a UI to that to kind of define those packet captures. And we have a mapping editor that we're developing called Terranova, which I'll show later as well. So, I mean, the gist is there is we have kind of a big suite of things that we work on. Pretty much all of those things have open source components. And so there's kind of two flavors of open source always in my mind. There's one, you develop something, you just kind of throw it over the wall. If anybody wants to download it, great. But maybe you're not actively, too worried about building a community and things like that, right? And then there's kind of the other type, which is, you have an actual community around the product. You have a governance structure. You maybe have multiple partners and things like that. So obviously our big one for a long time has been perfSONAR. You'll see the organizations listed here. I think they're all represented at this meeting that have been developing that for quite a while. And I'm just going to briefly mention there is kind of a new one coming up called Metronova that's looking at some of the types of data like perfSONAR doesn't collect, and basically figuring out how we can share some of the common ideas that we see in venues like this between the various organizations listed, and how we can help the broader community. And so at just kind of a plug at Internet2's Community Exchange, there's going to be a bigger presentation on that if you're interested in learning more. So let's get into ESNet's actual infrastructure here. So there's a lot of different pieces. So if we start out at kind of like what we have on the actual network in terms of, extra stuff beyond what the routers and, transponders and whatever else can generate. We have hosts, as I mentioned, at each of the routers. So basically the tally's over 50, it's 55 or something like that. And so basically we have servers, we have 3 interfaces on those servers. One of them is a 100 gig interface for throughput. Then we have, I believe they're both 10 gig interfaces. One's just a management interface, and the other is where we basically send our latency tests out of. So in the perfSONAR context, that's OAMP. Each of the throughput and latency interfaces actually have a VLAN on the, or I'm sorry, not, is it implemented as VLAN? Anyways, they have sub interfaces. One that kind of goes across kind of the main ESNet backbone, and the other one that's kind of routed over LHC1. So we can also do LHC1 testing as well. We just run the perfSONAR test point, so we don't run like a full toolkit and have GUIs at each of the points. We run measurements there, and then we centrally archive them to our Elastic cluster, which is part of Stardust, which I'll be talking more about in a few slides. So basically we have everything centrally loaded there. So that's the perfSONAR piece. Another thing that we have kind of running at each of the sites is these high touch servers. And so we're still kind of learning how to best leverage these, but basically you can kind of see the architecture here. We have some pretty beefy servers with these FPGAs in them. And they essentially get a mirror of the traffic from the routers, and basically just look at the headers, and then can do all sorts of kind of analysis and things like that. And then we also, the idea is those get pushed into a central database as well. The High Touch project's actually been exploring using ClickHouse. So we're kind of multi-data source in that sense. Everything else we have goes into Elastic. We're still working on getting that instance into production. So that's not fully production as of today, but it is very close to being so. But that is another tool we have at our disposal, and still kind of learning how to best leverage that. So All right, so we have all this stuff. We have perfSONAR nodes, we have high touch nodes, we have, the devices themselves that have a bunch of stats that you can get out of them, right? So how do we bring this all together? And that's the Stardust thing that I mentioned. So you'll see a very high level diagram over here, but to kind of give you an idea of what we're talking about, the data store is Elasticsearch, except for in the case of high touch, which I just mentioned. Basically, all that data, we collect it, however we can, essentially. And then the data processing pipeline is they all forward it to a Kafka instance, that is run through then various Logstash pipelines that add in a bunch of metadata. So again, a lot of stuff you saw on Doug's slides with NetSage, so stuff like the science registry, information from places like CADA and MaxMind, and we have an internal database called ESDB, which is our inventory system. So we pull in info from there. And so
do you measure energy? Do you also measure energy consumption?
Yep, we get that too. So what we actually collect. So from the routers, we collect flow information. Currently, we use SNMP. We have prototype streaming telemetry. We actually plan to move to that because it solves some problems with essentially the routers can't keep up with all the stats that we want out of SNMP. So hopefully we'll have that in place soon. We collect, the most recent addition was BMP. So BGP monitoring protocol. So that gives us information about like various stats about the peers that each router peers with. We actually correlate the BGP tables as well with the flow data, so we can do some AS path lookups. We talk to the PDUs, so energy consumption that was just mentioned, that goes in there. We collect stats about the devices themselves, so CPU usage, memory, things like that. We collect similar info out of our optical system, specifically the transponders. We don't go all the way down to the line system, so it's basically just the transponders at this point. I already mentioned perfSONAR and high touch data. We pull in incident data so we can correlate with ServiceNow. We pull in these things called LHC fireflies. So every time, these are kind of a prototype as well, but they're big this week with the data challenge. So the LHC has like XRT and some other things instrumented to send these little packets whenever a flow starts to like tell you which experiment and activity they're associated with. So we're collecting those. So basically we collect a lot of stuff is the gist of it, and kind of bring it all together. And I'm happy to answer more questions about any one of those two once we get to that segment. So then we have a bunch of windows into the data itself. So I've kind of listed them all here. We have kind of our main my.es.net portal, which is kind of curated views that's publicly accessible that people can see. We have another public page, public.stardust.es.net, with some like LHC specific views mostly is what's there now, but that's a Grafana dashboard. And it just kind of allows us to be a little bit more dynamic and flexible with building stuff because it's easy to edit Grafana. We'll probably merge those two things at some point. We also have an internal Grafana dashboard with a lot more information, as you can imagine, that's accessible to our ESnet engineers. And then we have, your standard Mad Dash dashboard for perfSONAR, which we also plan to merge with these other views here shortly. One other thing I want to mention that we're working on, so I know mapping was mentioned earlier. So that's a big use case for us as well. So right now under development, we have a map editor in place. So the idea is basically you can have kind of a single source of truth. You can kind of grab data out of like things like Stardust and ESDB to kind of help populate the map. But for those of you who've ever played with mapping, it's a lot more art than science, right? People all have different views of what they think the network should look like. And there's like exceptions all over the place and where they want things positioned and all that. So we're trying to build an editor to basically accommodate that. So it can talk to the source of truth, kind of give you a starting point, and you can move things around and stuff like that. And then it's pretty cool. It's got multiple export formats. So you can like embed it in Grafana, if you just want straight SVG or JavaScript, just like embedded JavaScript, it can kind of generate those things for you. And it also can do different views. It doesn't just have to be geographic. It can be more logical layouts like you'll see on the bottom here. So it's really kind of an ambitious and really cool project. It's not quite ready for prime time yet. And I think initially it's going to be focused internally on ESnet. And I think with all stuff, we'll probably evaluate that as we go forward. But kind of a cool project that's happening these days. And so I know I'm approaching my time, so this is my last slide. So this is probably some of the more interesting stuff. So we obviously have a bunch of data, we have a bunch of tools. You know, what are we dealing with today, right? What are the big challenges? So I think kind of consolidating those views and just helping people make sense of the data. Like we have a lot of it. So like, how do you present that in useful ways? And you know, when people need to drill down, what's the best way to do that so they find what they're after? We are still looking at adding new data sources always. So I mentioned streaming telemetry as one, and that'll open the doors for us to add a few data points that we either can't find in SNMP or we're concerned SNMP won't be able to keep up. And I think probably the biggest area of focus really is non-technical work, right? When you build these types of things, I think training, even just internally, to make sure everybody's on the same page or at the same level within the engineering team. We definitely have certain power users, but we want to make sure everybody is aware of what's available and the data that we have available. So I think that's a big focus, and obviously expanding the collaboration efforts. And I think I'm at time. So yeah.
Thank you, Andy. We'll take the question at the end of this second part of the workshop. And let's continue with the next presentation from Mark Feit of Internet2.
All right. Everybody see that okay?
Yes, we can see
okay. Many of you know me, some of you don't. I'm Mark Feit from Internet2, and I'm going to talk a little bit about our perfSONAR deployment. This is a little bit more of a nuts and bolts talk. We sort of benefit a lot, I think, from some of the stuff that Global NOC does, because they, you know, we use them to operate our network. So this is going to be a little bit more just about the deployment and some of the things that we ran into doing it. So if you're not too familiar with Internet2, I'm sure probably some of you are, but we build and operate the National Research and Education Network in the US. We're a nonprofit consortium. We've got somewhere in the neighborhood of 450 members. We operate a 400 gigabit per second backbone, more than that on some routes. That's spread across 47 plus 1 points of presence. The extra one is under construction at the moment. We connect to 46 regional and state networks, and we offer about 300,000 routes to some of our commercial peers, which some of our higher ed members like, because it takes things like Netflix traffic off of their commodity networks. Little bit of history lesson here, and a lot of this is well before my time, so I have to kind of give a nod to Matt Z for having filled me in on some of this. Very early on, our first network, which was called Abilene, had a thing called Surveyor that was GPS time disciplined and didn't do ad hoc measurements. I'm not actually super familiar with what it measured, but I'm assuming it was probably some things like latency and so on. By 2003, Surveyor had been replaced by a thing called Observatory that incorporated some of the tools that are a little more familiar and ended up as part of perfSONAR, so BWCTL, OAMP, and I guess the now obsolete Throughlay. By 2007, we were running perfSONAR in earnest. And in 2013, we had put together this thing called the Performance Assurance Service, or PAS, which included a full set of perfSONAR nodes for our internal use and 3 for public use. Those systems kind of fell into disrepair over the years. And when we put in NGI, which is the current iteration of the network, we kept the internal use perfSONAR nodes, and late last year, we announced that there are also a set of public perfSONAR nodes available. I'll talk about those in a second as well. So our deployment, as I mentioned, we have 47 POPs. We have perfSONAR in all of them now, including for public use, as I mentioned. So that's kind of a big thing for us. We're really happy to do that, and I think it will probably simplify troubleshooting for a number of our members. The per POP deployment features up to 4 perfSONAR nodes. The 2 big ones are our internal perfSONAR node, which is a 100 gigabit per second node. In most of our POPs, it plugs into the first core router. In our split interconnect POPs, we have 3 or 4 different POP architectures, and split interconnects just a little different, and we plug into the aggregation routers there. Access to those is very limited to select Internet2 networks only, so it is truly internal use. The public perfSONAR node is pretty much the same. It's configured the same way. It's connected the same way, and access to that is available from RNE and I2PX. Additionally, in each POP, we have two 10 gigabit per second nodes available, up to 2 of those, and those are placed at network engineering's discretion, just as far as where they want it topologically. I'll put in a quick plug for our public PerSONAR nodes here. They are open for use. It's just the popcode.ps.internet2.edu is the host name. They're available on IPv4 and v6, and as I said earlier, via our RNE and I2PX verse. We do not have separate addresses for each verse available. If that becomes something that people demand, we'll probably reconfigure for that as well. Not going to dwell too much on this. In case you download the slides, here's a directory of all of our POPs and their codes. So real quick, I'll just cover kind of what we measure, and it's probably not going to be too big a surprise to anybody. The usual suspects, of course, latency, jitter, loss, and path. We put a lot less emphasis on throughput than we used to. Turns out that it generates a whole lot of traffic and not necessarily for a whole lot of benefit either. Latency and loss will tell us a lot about how TCP is going to behave. And while we're still doing regular throughput in some areas, I think we're sort of shifting more toward ad hoc for spot checking and things like that. One of my observations, and since I don't actually use our PerSONAR systems directly, I kind of write the software and help get them deployed. But one of the things that I learned managing the PerSONAR deployment on SciNet is that having 10 gigabit per second systems is often more than enough to suss out problems. We discovered even on low latency networks like SciNet, there was plenty of bandwidth to be lost when problems cropped up. You'd see these fall down to 2 or 3 gigabits per second and then shoot almost back up to 10 when the problems went away. So I'm going to spend the rest of this talk on how we made it happen. One of the things that we kind of fixed when we deployed NGI was the installation of what I like to refer to as a sport utility server in each of our POPs, and its job primarily is running PerSONAR. We have a few places where we do some packet capture just for troubleshooting, and we have room to do other applications as we come up with them. The machines themselves were kind of configured light overkill for future proofing. So we got lots of cores, lots of memory, and a reasonable amount of disk space. It is expandable, but frankly, very little of what we do on those systems is storage intensive. The systems themselves, most of them are Dell R6515s, which is kind of one of their standard one rack unit systems. Those were installed during the NGI build out a couple of years ago. The POP that we currently have under construction in Boston is going to have a 6615, which is pretty much the same machine, just kind of this year's model. But they're all pretty much kind of the same thing. It's an AMD 7402, that gives us 48 threads at 2.8 gigahertz. We put 128 gigs of memory in them. And the business end of these things, in addition to the low-speed management interfaces, are a pair of Broadcom 10 gig Ethernets. And we added to the system a Mellanox Connect X5 that gives us 200 gig ports that we use as well. The OS on these things is ALMA Linux 9. Probably will stay that way for the time being. I think in the future it's going to depend on Red Hat's behavior as far as source code and things like that, and whether or not ALMA continues to be available. The architecture of these things is a variation on something that we did for development that's actually worked out really well. So on the left side, we have a couple of low-speed interfaces that connect up to our internal management network. One connects to the lights out management card, which is iDRAC in Dell's terminology. And the management interface for the OS goes there as well. On the OS, we run a container environment. It's currently Podman. It has been Docker in the past. And we run containers with PerSONAR in each one, and each having a dedicated measurement interface. Probably anything else that we do will be containerized as well, because it's just sort of convenient. But as I said, right now we're not doing anything other than PerSONAR on these things. What makes all this stuff work is a network driver that's present both in Docker and Podman called Mac VLAN, which takes an interface on the host that it binds it straight into a container as if it was, as if it was sort of a bare metal thing. It bypasses whatever little additional overhead there was from passing the interface in any other way. We bought 2 of these machines before we wrote the big check for the other 50. Put 2 of them back to back in the lab with a piece of fiber between them, just to kind of see what we could get them to do. And generally speaking, what we discovered was that the difference between what we got out of them, containerized versus bare metal, was pretty much negligible. So needless to say, we went with those. We don't assign an address on the host, and that's just to prevent external access to the OS. But the big thing that this gives us is multiple perfSONAR nodes on the same hardware, because the hardware is pretty capable, and it didn't make a whole lot of sense to put multiple machines in when we could just do one. We've kind of kicked around the idea of building resource management into pscheduler, but it's a really tough nut to crack. It's a harder nut to crack and get it right, and the amount of labor that was involved just was not worth the effort when we can do something like this. What we do to make these things perform, the 100 gig containers each get 12 cores, 32 gigs of dedicated memory, and we do some tuning of IRQ affinity and a few other things on the host system to make them perform as best we can. In the lab, we were getting pretty well north of 93 gigabits per second out of them, so we were reasonably happy with that. The 10 gig interface containers are pretty much scavengers. So they just sort of grab whatever threads they can, whatever memory they can. We haven't done any special performance tuning from them because, frankly, it's really easy to saturate those interfaces with what's available. We may change the way we do that depending on what other load we put on the system in the future. But for right now, it was kind of the easy way to go, I guess. One of the things that we ran into during this deployment was what I've come to call the /31 problem. Internet 2 uses IPv4/31s internally fairly extensively for point-to-point connections because obviously it cuts our address use in half, which keeps our network engineers and presumably the folks over at NREN happy. What we discovered initially was that Docker couldn't handle them at all. And one July afternoon in 2021, I went wading through the source code to figure out why and fixed it. And sent them in a PR that didn't show up until in production code until about 18 months later. By that time, we had upgraded our OS, and the default container environment there was Podman, which turned out to be just fine with them. Its HTTP API is a little confused about them, and that may be a future spelunking project for me. So that's just kind of something to watch out for if you're deploying in containers. We also went through our journey with this, encompassed a lot of development tools. The initial cut was with Ansible for expediency, but what we discovered is that our particular configuration of the networks was unusual enough that it didn't do real well detecting whether or not there was a change. So what ended up happening was every time we ran Ansible, it would recreate the networks, and that would result in the container being destroyed and rebuilt, which we just decided was not good. We did a quick shift to Salt just to see if that would improve anything. We use Salt for a whole bunch of other things, including much of the configuration on these machines. It was stymied by the same problem, and I think the root of that is its module's use of the HTTP API in Podman. So we ended up again for expediency with shell scripts, and we tied a bunch of them together, kind of in a sort of a mini Ansible, I guess, for one-touch provisioning of each system, so we could get the things going. And it was all done up in very small pieces, so that we could start moving them into Salt, which is something we're just starting to do now. Now that everything is fairly stable. So that was pretty much all I had. I had kind of left a minute or so for Q&A, but I think, as they say in the U.S. Congress, I will yield my time for the rest of this. If you have questions later, please drop me a line. I'm mfeit@internet2.edu. Thanks.
Yeah, I see that Edgar has a question, but I suggest we take all the question at the end of this, the second part of the workshop. And so I'll get back to you, and we'll just continue with a presentation from Daniel Neto from RNP about perfSONAR deployments.
Okay. Hello, everyone. Can you hear me?
Yes, we can hear you fine.
Okay. So, hello, good morning, everyone. Good afternoon or evening. I'm Daniel Neto from I'm software engineer at RNP in Brazil. And I'm going to talk a little bit about our perfSONAR deployments here at RNP and a little bit more than just how we measure our networks, how we monitor everything here. So first of all, a little introduction. So what's RNP, for those who don't know? RNP is the Brazilian National Research and Education Network. So it's responsible for build and operate the network that connects to all institutions, higher education and research institutions in Brazil, museums, health establishments, and it's funded by the different ministries, so the government, since it's not a non-profitable organization. And the network that RNP is responsible to manage is called IP network. So this is a play of words with the name of a tree, very, very common tree in the Atlantic forest in Brazil. It's called IP. And the IP network is present in all across Brazil and all the states, 26 state capitals and the federal district. And there's a point of presence, and we are there. We have a perfSONAR instance running there, and this is all cities there we are present. And to these points of presence, the clients are connected. These networks also connect to Europe to 100 gig length, and United States to 200 gig length, and Africa as well to 100 gig length. Our perfSONAR deployments are mostly 10 gigs now running this, but we are planning on starting testing with 100 gigs server and later this year. So to monitor this network, the IP network, the MoneyP service was created, and this is the service I'm working on since 2019. And it is composed of three different, mainly components. The one responsible for monitoring the backbone, so the connection between the points of presence, and it's basic perfSONAR things. We have a perfSONAR test point, and all of our points of presence, perfSONAR archive, central archive, tools for visuals, the results, dashboard, Grafana, and also we have Madash still running, and a PWA to set everything up. We're running all kinds of tests, so mainly RTTP and packet loss are used by engineers here at NEP to see how the quality of the network, how it is running. We also run one-way latence, traceroute, and bandwidth. There we have a dedicated network interface in each of deployments to run both cubic and BBR tests, bandwidth tests. We also have this is specific to this is a very development that we did here. Is a network performance tester. Is a tool used by engineers, POP engineers, to validate the SLA of the network that connects the POP to the client. So every time a client wants to connect to our network, the POP is responsible for contracting the network provider, local network provider, and needs to validate if the SLA, download, and if the speed, network speed and latency are all being under some limits of quality. And we have a web server running on Laravel, PHP, and we have also Ansible to connect and to configure all network devices that we need to use to run these tests. And we're using perfSONAR tools, the containers, to run tests. And lastly, we have, this is a more recent service. We have a speed test on all of our deployments as well. And this is basically a speed test that runs on your browser measure your connection to the POP, and it runs an NDT server, NDT version 7. This is a MLab tool that we are running, and it collects, it gets TCP statistics from TCP info from the kernel, and it runs also on BBR, TCP congestion control algorithm, and it uses WebSockets. And recently we started this project doing our own instance, but then recently we decided we started a collaboration with MLab. So our goal with this collaboration is publish all the measurements that we get from these speed tests to the BigQuery. And this is a work in progress. And we hope also to add our servers to their pool of servers in Brazil. So everyone who wants to measure the connection to our points of presence, they can use our servers. And here's just an overview of how we measure the different levels of measurement that we have. So in the big scale between points of presence, between using that backbone service perfSONAR. So we measure all those, the quality of that connection between these points of presence. And inside the city, we use those other two services. We want to measure the quality of the connection from the client CP, the customer premise equipment, to the point of presence, and the speed test that based on MLab that the client of the end user of the client network can measure the quality to the point of presence network. And so what is the architecture that we have for all those services? So this is just overall, like I said, we have 27 points of presence. And on those, we have a virtual machine with different, tuned to make sure the virtualization layer doesn't impact the performance of the measurements. So the network interfaces are set to pass through, and we have some tuning to minimize the latency in the measurements. And we also have a central archive of the virtual machine and a dedicated network tester machine that connects to those POPs on demand when the test needed to be scheduled. And everything is configured and set up with AWX. That is a Ansible Power open source instance that we have here. And we're using Ansible to configure everything. So inside the central archive architecture, this is how we are running everything. Is basic everything Docker container. We recently decided to move to change our host OS. We used CentOS 7 before, but now we're going with Ubuntu 22. We're still in the transition. So we're validating this architecture. And on top of the Ubuntu 22, we run Docker containers. This is a basic archive installation, but instead of installing the applications on the host itself, we are running official containers. And we also have an Almond container to make sure the API open source is still understandable by our Madash and the PWA. So everything is running in Docker. So it's easy for us to move the transition is being really easy with this approach of using containers. And the POP is a little bit different. So we have a test point. Tools, is everything also containers. The tools are created on demand when running a test using the network, the measurement tester. And the entity here it has 3 different containers: the web interface, the server itself, there we can connect it directly if you want to run a CLI test. And the jostler is responsible for sending the data from the measure data to the data center of MLab. And this just mentioned that we have a dedicated network interface just to run entity tests. And the test point has use two different network interface, one dedicated for bandwidth tests and another one to all of the tests. And the tools are used, they share the network interface used to bandwidth to validate the client connection when needed. So it is a network interface that is shared. And since I mentioned the NDT, here's our interface that we have right now. The speed test measure like download, upload, RTT, jitter, retransmissions. And these are all measurements that are sent to their data center. And these will be available for researchers that want to use this data to get the idea of what is the quality of the network across Brazil. And the network performance test is the other service that I mentioned. Here's how the architecture, how we run tests. So when a client wants to connect to our network, EP network, we need to validate. So we need to run a field test, TCP, UDP. We also run tests to make sure the latency is in the limit of quality. And we start those two iPerf instances and run. We need previously to set this in private network. We're using also a VLAN, dedicated VLAN, to connect to the client, and we run a series of tests that is scheduled by the POP engineers, and they decided they want to run our test with longer test, a short test, TCP, UDP, and then we generate a report after this measurement, and with this report is used to document, to prove that the network provider is providing a quality network connection. And also here a little talk about our recent project that I started last year, so the second part of last year, with 3 students, university students in RMP, to work with, since now we have this new architecture based on open source, we can work on different visualizations. So we started testing different plugins, to Grafana plugins, to reveal trace HAL results. So those are some pictures of our that we are using, that present now with Grafana, and we can see here the path that follows. Here, this picture, the first picture, is from all other cities from Brasilia, the capital, through to all of the cities. So we have the idea what the path the package is following, and the other one is from all different places to Rio de Janeiro. So it's different from the source and destination. We can select the source and destination, different ones, and see what is the path the packages are following and how many hops that we have from one point of presence to the other. And if you take a closer look to each point of that, we can see different IP addresses related to each path that is followed. And this project is still running, and the idea this year we are going to use all those data to analytics on top of those data. So we working on machine learning and trying to get some information from all those data measured. And well, that's all I had. Just brief overview. Thanks.
Okay, thank you, Daniel, and thank you for all the presenters being right on time and keeping to the schedule this whole workshop. We have now time for another question and answer session. And maybe I will get back to Edgar with the question he had following Mark talk, I guess.
Yes. Hi there. My name is Edgar. For the ones that don't know me, I work in FCCN, the Portuguese NREN. So I was wondering, we currently try to deploy in Docker Swarm containers. The perfSONAR test point, we were successfully with the help of Lætitia and the GÉANT team. We also were able to deploy in containers the meddash, but we couldn't deploy in containers the OpenSearch database for a number of errors we were having since it said it needed to be like PID1 in system, and we couldn't get it right because Docker needed to run in PID1. Were you able to get the database inside the container?
So yeah.
So I don't think you guys don't even run an archive, do you, Mark? Is that right?
No, because all of that stuff goes into global knock.
Okay.
Yeah. So I have been able to run OpenSearch in a container before. The challenge with running OpenSearch in a container is perfSONAR doesn't currently provide packages to do all the setup. Like if you do an install of the perfSONAR archive package, it doesn't just install OpenSearch, it'll do a bunch of setup and stuff. So you kind of got to do that. I mean, it is possible to do, but you have to do it by hand too. Is the other big challenge there. I haven't played with the OpenSearch container or not. I'm assuming you're just using the standard OpenSearch container that they make available. I haven't played with it in a while. I don't remember anything special about it, but yeah, that's an interesting data point. So,
okay, thank you.
Yeah, thank you, Edgar. I see Ivan has a question.
Well, I have several questions, and actually I would like to go back to the presentation from Andy. I find it quite interesting, and actually there are even some challenges, and there especially on the perfSONAR slide, where there were two interfaces as far as I understood, one attached to the LHC and another one to the research and education network, and both of them being served from one node, or was that just
correct? Yeah. So every single node. So we have one node. There are three physical interfaces on them. So one of them is the management interface, so we can ignore that one. The other two are basically what we call the throughput interface and the latency interface, right? So one's 100 gig interface, that's where we send all the iPerf. The other one's latency, that's where we send all the OAMP, essentially. So each of those physical interfaces then have two sub interfaces, right? And one is kind of on the main kind of ESnet backbone. The other one is on the LHC1 L3 VPN, essentially, but it's on the same physical interface as on the host as the other ones.
Yes, on the same host.
Yeah, so this is a change from how we've done it in the past. So we did used to have dedicated boxes that were just for LHC1, and they were only at a few places. I can't remember if we had like 5 of them or something like that. Maybe it was 3 to 5 range, right? So when we did this recent kind of generation of perfSONAR boxes in the past couple of years, we basically made the decision to basically merge those things. Basically because it allows us now to have LHC1 at every single point, which is super helpful. So
yes, but the problem here that probably I'm not sure you're struggling with is that now you have to accommodate so many measurements on one schedule.
Yeah, we seem to. I mean, you have to be conscious of that. The iPerf tests are the biggest ones you have to worry about, right? Because they're exclusive.
It's the schedule, actually. It's not the throughput that I'm worried.
I think part of it too, so that's actually not it hasn't been a huge issue for us currently, but you're not wrong, right? Like there is a point where it becomes an issue. I think part of it too, and Ken's on it, I think just overall, we probably need to rethink some of our meshes too. I mean, that's a constant process, right? To avoid that, and both, I think there's kind of been a long-standing thing with personas. I mean, maybe I shouldn't speak for everyone here, but you just kind of throw out a bunch of tests at it, right? Like maybe you go these places a lot and you're not really thinking about like which links you're testing and things like that always. And so maybe being a little bit more deliberate with that type of consideration when designing meshes starts to come into play. But yeah.
So, but you're achieving that through some special limitations somehow, or kind of.
There's really no secret sauce here. I mean,
or there is no such interest.
Yeah, I mean, we just let pscheduler sort it out. So, and if it doesn't work, we just complain to Mark. So, same model as always. Yeah. So no, I mean, we haven't had to like really explicitly get more worried about that than we already were, I should say. Yeah, I mean, it's pretty standard PerSONAR stuff, right? I mean, we set the source and destination, and we, because we have multiple interfaces, we have that little stupid source routing script that PerSONAR has shipped forever that we have to run. But I mean, it just kind of works. Like, there's really no secret sauce there in terms of getting it to go across LHC1 versus the main network. And we didn't have to go too crazy with worrying about having too many tests and things like that so far. I mean, it helps too. These are pretty beefy boxes that we got, just because we could, and we designed them to go, 100 gigs. So it's not like we're talking about, the small nodes or anything like that. Then you have to be more worried about overloading those. But it also helps we don't run the archive locally, since we're not running Toolkit. We don't have to worry about any of that overhead. So it's just all dedicated to testing.
Okay. Okay, so both on the LHC and the research and education network, and over, because I know you have a huge mesh there, you're managing somehow to accommodate everything on one schedule.
So I mean, we've never done like a full mesh. Like you'll never see a giant, if you think of it in terms of mad dash grids, right? We've never done like a giant grid of throughput tests, for example. We've always been a little bit more targeted with those. So we do have big grids of like OM tests, but those can run.
But these are all
right. Okay. So it's fine. So I mean, I guess maybe we didn't make too big a new considerations there. I mean, again, it's something you always have to be conscious of when doing this. But I don't remember running into any specific issues when we started scaling up. But maybe we front loaded that in our brains when Ken, and myself and others were looking at it to worry about that. So.
Okay. And my other question is to Mark, actually. He mentions there that they had some difficulties or problems with management with Docker of the containers. But I was wondering, and then he mentioned also Podman, but I was wondering about Kubernetes, for example, because you could be managing the containers through Kubernetes, and probably it's even more clear there, or clean, I would say. And also there is the OpenStack, for a kind of the virtual machine experience. And so did you guys have that?
So yeah, Kubernetes would be delightful, except that it is really nitpicky about control of the network interfaces. And you actually cannot configure a container with Kubernetes using the network configuration that we want. So as much as it would be nice to have that stuff just kind of popped out there, we can't make it say this interface is, and this is last I looked anyway, we can't say this interface is dedicated to this container and it's Mac VLAN. Kubernetes was I don't think was built for that use case. So that's why we're not using it.
Okay. Thanks.
Sorry, I'm Paul Mebal from GÉANT and NREN in Paris, in France. I have a question in regards to Daniel Neto presentation. when you mention Ansible with the AWS tool, what was the aim? Is it to manage or configure the? I think you might have some ESXi's hosting, some VMs, some personal VMs. Is the Ansible role to manage, to provision these VMs? How do you practically use Ansible in that context?
So actually the VM are not managed by us. The IT team provided the VM for us. We're using Ansible to configure the Docker firewall and everything inside the virtual machine. And we're using some playbooks. Actually, yeah, we shared this with Persona team back, and it's to create the Docker container, the test point container, all of the containers we are running. So we are managing them via Ansible, and we also running some to setting everything up like that makes the performance okay for us to test. Just inside the container, just inside the virtual machine, not the virtual machine itself.
So it's to say that you have like Docker on top of the virtual machine stack. And
yeah,
okay.
And like I said, the virtual machine we tuned that to together with the IT team to make sure that the virtualization layer doesn't impact the measurements. So we have those network interfaces dedicated to our virtual machine, and we are also running. There are some settings to minimize the impact of the delay, the latency in the measurements. So.
Okay. Okay. Thank you.
Thank you, Paul, and thank you, Daniel, for the answer. Is there some other question? So to add to the Edgar's question about Wi-Fi monitoring and headroom monitoring in the chat, it might be worth looking at WiFiMon as well and see if it can help you there. But it needs to run on different hardware than the perfSONAR hardware.
Oh, okay. I was wondering if there was some integrations with directly with perfSONAR being made, but yeah, thank you.
No, for WiFiMon and perfSONAR, no.
And it's do you think in the future maybe it will happen, or is it just something that's not on the roadmap?
So no, that we actually evaluated the possibility of running both perfSONAR and WiFiMon on the same hardware, but WiFiMon relies on very small hardware probes, Raspberry Pis actually, and perfSONAR demands more resources that the Raspberry Pi can deliver. So it really doesn't make much sense to try to run both set of software from the same hardware. And if you're using WiFiMon, you're better having deploy some other kind of probes and some other kind of hardware to help you with that.
Okay. It's just because we're currently testing some scripting in the servers that are running perfSONAR, the perfSONAR test points. We have one in each university campus, and we are testing just in like authentication of headroom, not like testing the quality of the network, but for testing the authentication, it's proven pretty useful. even though it's okay, it's not perfect because you're not testing the quality of the networks in your office. You're testing if the EduCom can be authenticated in that institution with all the accounts of the other institutions. So I was wondering if you reached the same conclusion, of course.
Yeah, so we didn't go as far as testing all that, so you probably have more experience that we have, but maybe what we can do is follow up offline on some other call with setting up a discussion with the developer from University of Michigan so that you can share results and see how they're doing it with perfSONAR then.
Yeah. We're still in like pilot mode, but once we get more results, for sure.
Michigan is too, so you're pretty much in the same spot.
Okay.
So yeah, I mean, I can kind of, I mean, sort of what they were after was probably sort of similar, a super. Learn to speak here. What they were after was kind of a superset, I think, of what you might be after, which is they wanted to be able to do go find all the SIDs and log into them, authenticate, and then do some quality testing just to make sure it works. So, and like I said in my comment in chat, I'm not quite sure what the state of those are as far as how ready they are for prime time. But it's the architecture is certainly there to do it.
Okay. Any work has been done for measuring 5G performance or the performance of 5G?
Well, I mean, I guess as far as if you're just looking at how IP performs, there's no reason that you couldn't put, say, a perfSONAR node at one end of something that gets you onto 5G, and operate that way. As far as I know, nobody has done any. Nobody's done any kind of like low level, or nobody in this space anyway has done any kind of real low level performance measurement or anything else like that.
Yeah,
go ahead, Andy.
Yeah, I've had some discussions with a few people internally here because we potentially could have a project that would be interested in that type of thing. But I haven't, I mean, it's been very preliminary. And I mean, I think at this point too, it's like, we don't know even what we'd want to look at. I do think if people have done stuff in that space and know, like, kind of as with all pScheduler stuff, if they know good tools to get like useful stats about, signal strength or whatever it is that you care about with 5G, I think that'd be super interesting. So.
Yeah, and even if we don't support that stuff now, and this is kind of the standard thing that I tell anybody that's got something that we don't explicitly support right now, we can measure pretty much everything. What we need to get there is just some expertise from somebody who's got tools they like and knows how to use them. And then we can do most of the integration work because it's not rocket science.
Okay, thank you very much. Is there some other last minute question? We're getting close to the scheduled time for this workshop.
So a very quick question, and it may have been more pertinent to the previous session, but I mean, perfSONAR also has the ability to do traceroute, and the interface at the moment is quite primitive to display the results. I wondered whether there was any work ongoing to sort of make it a bit more elegant, to make it a bit more pretty, and also potentially tie in several different traceroutes from several different perfSONAR hosts, so you could get an overview of how the network, the topology of the network.
Yeah, so unfortunately I had to miss Letitia's 5.1 talk, but the big thing we're doing there is replacing all the visualization with Grafana stuff. So that current interface will be going away entirely. And so we're going to move all that to Grafana. So it should get better, but I mean, I think we have a lot more options basically with what we can do with the trace route data once we're there. Looking at just the perfSONAR data too, there's some kind of interesting visualizations we can do to display it. So at ESnet, we had a summer intern last year develop like a Grafana plugin for what's called like an arc diagram. So you can get like these kind of pretty pictures that show the path and things like that. I think you're also correct that if, basically we have some better options in terms of looking at trace routes across multiple tests. So like one thing you can do with OpenSearch is you can actually search for like IPs in the trace route or even IP ranges, I believe, because I believe we map that to the IP data type. And so then you can kind of get a list of trace routes there. One thing I've been playing around with, that you can kind of do when you have like SMP data as well, right? So this is obviously expanding a little bit outside the perfSONAR scope, is you get those IPs, and then those IPs obviously map to interfaces. You can get like interface counters too, which can be interesting, and there's lots of cool options there. So I think the short answer is yes, we're looking to make that better. The current one was written by some Dale guy from University of Wisconsin, so I'm pretty sure he doesn't work there. I always wondered where he ended up. So
I would also add to that there are a number of visualization tools for that stuff floating around out there. In a lot of ways, we're sort of at the moment anyway, we're sort of in the make measurements and do basic visualization of it. But perfSONAR is open enough that what comes out of it can be very easily sent to other things. So making it a tinker toy in the context of a bigger system is certainly something that we're designed for. We're kind of a small project. We don't have a huge number of developers, so there's a limit to how fancy we can get.
Andy, do you know Andy Bruce Nordman? He's in, I think he's in your lab, right?
I don't know that I do know that name. Is he doing something in the trace route space?
Yeah, can you put your email on the chat?
Yep.
So there's another tool that I had mentioned also in my perfSONAR 5.1 presentation, and this is microdep that's going to be optionally integrated with perfSONAR, and I see that Otto here is the main developer for microdep and the perfSONAR in integration, so I will let him explain a bit more about that maybe.
Yeah, sure. I can just show this. There will be hopefully a trace route tool as part of this optional package. So you probably see a map there, right? So this is sort of will be the view of this microdep service, which is based on the data set giving you this map, which is similar to all the maps you've seen today. Are events we've interpreted from trace routes, as well as just background latency tests. Yeah, we have a trace route viewer here, which you could bring up here. Here I actually look into interpretation of the data sets where we see relations between a gap we've observed and some route change based. So this is kind of correlating trace route data and background latency tests. And here we have an option to jump to a viewer. So I guess that's the kind of view you perhaps want to have instead of the traditional text-based. So here we have attempted to plot the path and from the beginning to the end. And well, actually, if you look at the IP address there, we have picked out this is the router we claim is the responsible one for this route change, which might have led to a gap of around 37 seconds. And if you look at the trace route here, you can then see that this is over here. So it's something happening while to the one of the core routers, it seems, in RNet, before the traffic flows over to Europe. So, well, a viewer coming up.
Yeah, right. Thank you, Otto. I see Tim has also raised his hand to comment.
Yeah.
So yeah, I was just coming back to the point about perfSONAR and how flexible it is. I think one of the really nice things I don't think has been mentioned today, and it's been very useful for the Data Challenge 24, the CERN-related experiments, is that you can use it to test changes in network configuration and the way you configure hosts and servers. So, for example, you can add the TCP BBR code to a perfSONAR server and then selectively with the minus congestion option choose to run a test with BBR or with Cubic. Similarly, you can use the MSS option to pick how larger frames you're using, so you can get jumbo frames and test those. So, and coupled with the fact that most of the RNE perfSONAR servers are open to third-party testing, it's quite a flexible and nice way of being able to test new things and how things would change. So I could run a test between one of the UK university perfSONAR servers and one on Internet 2 and compare BBR with Cubic, for example. And that's proved to be very useful. So we saw with one UK university that had some packet loss. It was getting a few hundred megabits a second from the States to it with regular TCP, and then was getting several gigabits a second with BBR, because BBR is not, it doesn't throttle back on packet loss. It uses different mechanisms. So yes, if you're interested in how the network performs and changing parameters, perfSONAR is very flexible for that, and it's something that we will be reporting on from the Data 24 challenges. That I'm one of the people involved with that, and I think that's a very nice feature that should be more widely advertised.
Thank you. So we'll probably going to close this workshop soon, unless there are some other additional questions. We are a bit over the allocated time, but I guess all interested people here have no problem with that. Just to close the workshop, I wanted to mention a few future events related to network performance and network monitoring in the coming month. So there is the Internet 2 Community Exchange that is coming up next month with a presentation of the Metronova new collaboration that Andy mentioned in his presentation. Then in April, we have the next SIG and GÉANT happening. There will be most probably a WiFiMon info share, but it's still to be scheduled. So you will receive more information about it in regular communication channels. The next SIGNOC meeting is also scheduled for the beginning of May. And then middle of May, we have the 4th European perfSONAR user workshop coming up that will be hosted by SICT in Norway. And then in June, the TNC 24 with, again, Metronova presentation and perfSONAR Grafana workshop on the last day of the conference on the Friday, to which you're invited to come. So we'll hopefully have perfSONAR 5.1 out at that point. And during this workshop, you will be able to get more information and more hands-on experience with putting together a new Grafana dashboard for your own usage and the benefit of your NOC probably. So that's yeah, the events I wanted to mention. Is there some more?
Yeah, just 2 questions. The events will be online except for TNC, right?
So all the events I mentioned here, no, actually, I think the community exchange is in person. The SIG and GN and the SIGNOC will be in person, but with remote participation possible as well. And the European perfSONAR user workshop will be on site, but with remote participation available as too.
Okay. The European will be happening where? I'm sorry, the workshop.
So the European perfSONAR user workshop is scheduled for the 14th to 16th of May.
Yeah, okay. Okay. Also,
Norway.
In Norway.
Okay, thank you. For the last question, just to ask you, we were feeling some trouble in OpenSearch database because the database was saving the test points results using index. We had the need to swap to data streams. If that's happening to somebody, maybe we can help you, or you can tell us your experience. But we were feeling this problem because we were lacking shards in the database. Just an FYI.
That should have been fixed to that whatever release was in September, I believe, of this year of perfSONAR. It should have migrated you to data streams, so that'd be interesting if it didn't. But that was exactly how it got fixed.
Okay.
But it should have automatically happened if I don't remember if that's like 504 or something like that. I'd have to look, but it's somewhere around there.
Okay, okay. So maybe I just didn't add the most recent version at the time. Yeah, I was just telling you about our fix.
Yep. Yeah. That was the right fix. That's exactly.
That was exactly
what we did. So.
Okay. Thank you.
Yep.
So my Kat has just come to join me to ask where she can ask networking performance and monitoring questions between meetings. She's very keen to know. In all seriousness, we have a few lists that are focused on things like perfSONAR, and there is an NREN Slack. But is there, if you want to talk about the sort of things that have come up here, is there a global place where we can do it? What do you think, Lætitia and Andy?
Yeah, I don't think we have a dedicated place for that, except, like Mark mentioned, the perfSONAR, but it's really focused on perfSONAR usage and installation. Maybe it would be the right time to create a new mailing list or a new. We can also just open a Slack channel on the NREN Slack space, for example, as well.
So, I don't know what it's always hard to find something that everyone likes, but maybe something when you send a follow-up after the event to thank everyone and with a pointer to the slides, you could maybe make a couple of suggestions. Have a think about it.
Yeah, that's a good idea. We'll discuss that internally and then write back to the list of participants.
Yeah, certainly perfSONAR user is obviously good for perfSONAR, but more broadly, it would be kind of handy.
You know what might be worth considering, Tim, and of course the time zone for this was completely way off for people in Europe, but there used to be, before Alan Winery retired, there was Perf Club, and that was just sort of a drop-in, bring your own topic sort of thing periodically.
First rule of Perf Club.
Nobody talks about Perf Club.
Well, I guess something like that would be kind of nice.
I mean, just sort of a stand around the water cooler and discuss your issues or talk about things you're doing, I think might be a worthwhile thing to do.
Yeah, I think there's been some nice discussion here. It would just be very nice to be able to continue it without waiting to the next event, whatever it was.
If you do it late enough in your day, then some of us on my side of the pond might actually be able to show up and participate.
Yeah, that's always the challenge, isn't it? All right, thanks.
Yeah. Well, right. So let me thank all of you, all the presenters for today, and good presentation. And we kept to the schedule. That was very, very nice. We had some nice discussion and questions and answer, I guess. So thank you everyone for participating, and yeah, let's keep in touch. We'll keep you posted about new events and other ways of communicating.
Yeah, thank you so much for doing all this.